In the vast emptiness of the cosmos, where light travels for billions of years before meeting another star, there exists a silent force that binds everything together. It does not shine, it does not emit sound, and yet it shapes the motion of planets, the birth of stars, and the structure of galaxies themselves. That force is gravity, the quiet architect of reality. From the smallest pebble resting on Earth's surface to the massive black holes that dwell in the hearts of galaxies, gravity governs the behavior of all mass. It is the weakest of the four known, fundamental interactions of nature, and yet, over long distances, it becomes the dominant one. The other three, electromagnetism, the strong nuclear force, and the weak nuclear force, operate on subatomic scales. But gravity's reach extends endlessly. It is the reason why planets circle stars, why galaxies cluster, and why space-time itself bends under the weight of matter. For most of human history, gravity was a mystery that could only be observed through its effects. Ancient astronomers watched the movements of the planets and noticed that they followed precise, repeating paths. The moon circled the Earth, and the Earth in turn moved around the Sunday. It was Isaac Newton who first revealed the hidden order behind this cosmic dance. In the late 17th century, Newton proposed that every mass in the universe attracts every other mass, with a force proportional to the product of their masses, and inversely proportional to the square of the distance between them. This law of universal gravitation unified the heavens and the Earth under one rule. The same force that pulls an apple to the ground is the force that keeps the moon in its orbit. But Newton's law described gravity as a pull that acted instantly across space. A convenient, but incomplete picture. More than 2 centuries later, Albert Einstein redefined the idea itself. In his general theory of relativity, published in 1915, gravity was no longer a force transmitted through space. It became the geometry of space-time itself. Matter and energy tell space-time how to curve, and curved space-time tells matter how to move. Planets follow the straightest possible paths through the warped fabric of the cosmos, paths that appear as orbits when viewed from a distance. What we feel as gravity is simply the curvature of space-time, guiding everything toward the densest regions of mass. To visualize this, imagine space-time as a vast, flexible sheet. A heavy object placed on it, like a star, creates a depression. Smaller objects, like planets, move along the curved surface created by that depression. They are not pulled by an invisible thread. They are simply following the natural curves of space-time. This insight replaced Newton's invisible force with a deeper understanding. Gravity is geometry, not attraction. Einstein's prediction transformed physics, and for decades, it remained a purely theoretical model. But as technology advanced, evidence began to confirm it in astonishing detail. The bending of light around the sun, observed during the solar eclipse of 1919, matched Einstein's equations perfectly. The precise timing of planetary motion, the behavior of clocks in satellites orbiting Earth, and even the motion of galaxies all affirmed that space-time curvature is real. In everyday life, we are too small to sense it directly, but every second that passes and every object that falls is guided by that same curvature. In the modern era, the discovery of gravitational waves provided the final proof that gravity is not just a static phenomenon, but a dynamic one. When two massive bodies like black holes or neutron stars orbit each other, they create ripples in the very fabric of space-time. These waves travel outward at the speed of light, stretching and compressing the universe as they go. In 2015, the Laser Interferometer Gravitational Wave Observatory, known as LIGO, detected such a ripple for the first time, confirming one of Einstein's most extraordinary predictions a century after he wrote it down. What LIGO measured was not sound or light, but a faint oscillation in the geometry of existence itself. Every structure in the universe, from the smallest moon to the largest supercluster, owes its shape and motion to gravity. It gathers dust and gas to form stars, compresses hydrogen until nuclear fusion ignites, and holds those burning spheres together for billions of years. Without gravity, there would be no planets, no atmosphere, and no life. It is the sculptor that turned a universe of scattered particles into galaxies, and galaxies into systems of order. And yet, for all its influence, gravity is still a mystery at its deepest level. The other three forces fit neatly into the framework of quantum mechanics, but gravity resists that unification. Physicists describe it with elegant equations on cosmic scales, but its behavior within atoms or at the center of a black hole remains uncertain. The search for a quantum theory of gravity, one that merges general relativity with quantum field theory, is one of the greatest challenges in modern physics. What we do know is that gravity does not only pull, it defines motion itself. Every orbit is a story of falling forever, without ever hitting the ground. The moon is constantly falling toward Earth, but because Earth curves away beneath it, the moon remains suspended in perpetual freefall. The same is true for Earth's orbit around the Sunday. Everything in the cosmos is falling, yet everything remains in balance because space-time itself guides those motions. If we could see the universe not through light, but through the geometry of its curvature, we would witness a grand pattern of invisible contours. Stars would appear as deep wells, planets as smaller depressions, and black holes as infinite drops in space-time, where even light cannot escape. The universe would look less like empty space and more like an ocean of invisible gravity wells, each influencing the others in a cosmic web of curvature. Gravity gives the universe its rhythm, the slow turn of galaxies, the spiral arms of stars, the orbit of moons, and the steady pull that keeps our feet on the ground. It governs not only where we are, but also how time flows. Near massive objects, time slows down slightly compared to regions farther away. Astronauts orbiting Earth experience time at a slightly different rate than people on the surface. This phenomenon, known as gravitational time dilation, is not science fiction. It is measured every day by the clocks aboard GPS satellites. Even the devices that guide airplanes and smartphones rely on adjustments calculated from Einstein's equations. The story of gravity is, in truth, the story of structure itself. Without it, the universe would be a featureless haze of particles drifting aimlessly. With it, matter finds form, energy finds motion, and the cosmos finds stability. From the earliest moments after the Big Bang, gravity acted as the organizer of chaos. It pulled hydrogen and helium into the first stars, ignited nuclear furnaces, and seeded the heavy elements that would one day form planets and life. Every atom in the human body was once forged in a star, held together by gravity's hand. In every sense, gravity is the architect of the cosmos and the silent foundation of existence. It is the thread that connects the infinitesimal with the infinite. But what if, against every law of physics, this curvature suddenly flattened and gravity vanished entirely? If gravity were to vanish, even for a moment, the universe would lose its shape. Every object now held in its graceful orbit would continue in a straight line, obeying only inertia. There would be no arcs, no returns, no binding of matter to matter. To imagine this is to imagine the unraveling of existence itself, because gravity does not simply keep things together. It defines how things move at all. But before we explore that impossible instant, it is worth pausing to understand just how deeply gravity is woven into the structure of everything we know. In the simplest terms, gravity gives space its geometry and time its rhythm. Remove it, and not only do objects drift apart, but the very fabric of motion and duration loses meaning. The universe, as we understand it, depends on the fact that mass tells space-time how to behave. Without that conversation, there is no cosmos, only chaos. The story of gravity's reach begins close to home. Earth's shape, from its core to its clouds, is sculpted by gravity's pull. The planet's roundness is a result of every particle of rock and metal falling toward the center, balanced by the outward pressure of rotation. Mountains rise only so high because gravity limits how tall structures can stand before collapsing under their own weight. The air we breathe is held close to the surface by the same pull, creating the layers of atmosphere that make weather, flight, and climate possible. The oceans, too, are bound by this invisible force, their tides responding to the combined influence of Earth's own mass and the gentle tug of the moon. Beyond our planet, gravity binds the solar system into a grand mechanical harmony. The planets follow precise elliptical paths defined by the interplay between their inertia and the sun's curved spacetime. Every comet that sweeps through the outer darkness is a relic of this same order, tracing a path carved not by physical ropes or magnets, but by the warping of the cosmic stage itself. Without gravity, there would be no orbital motion, no seasons, no sunrise or sunset. The familiar cycles that shape our sense of time would vanish. Even the sun, our nearest star, owes its life to gravity. In its core, immense gravitational pressure compresses hydrogen into helium through nuclear fusion, releasing the light and heat that sustain life on Earth. If gravity were weaker, the sun would fail to ignite. If stronger, it would burn out too quickly. Its very balance between collapse and explosion is what defines a stable star. This equilibrium, known as hydrostatic balance, is a delicate conversation between gravity pulling inward and radiation pushing outward. Disrupt that balance, and the sun would either swell uncontrollably or implode. Everywhere we look, from the spinning rings of Saturn to the frozen moons beyond Neptune, gravity dictates structure. It arranges the debris of planetary formation into belts, shepherds icy fragments into comets, and guides asteroids through vast orbital corridors. Even in the emptiest reaches of the solar system, where sunlight fades to a faint whisper, gravity still reigns. Its influence extends infinitely, though it weakens with distance, ensuring that every atom of the solar system still feels the faint pull of its central star. On larger scales, the same principle shapes galaxies. Each galaxy, like the Milky Way, is a rotating city of hundreds of billions of stars, bound together by their mutual gravitational attraction and by the unseen presence of dark matter. This dark component, detectable only through its gravitational effects, outweighs visible matter by roughly 5-to-1. Without it, galaxies could not hold themselves together at their observed rotational speeds. Gravity is not only the sculptor of visible forms, but also the silent evidence of what cannot be seen. When astronomers observe distant galaxies, they are looking back in time, seeing how gravity assembled the universe's first structures from the faint haze left after the Big Bang. Small fluctuations in the density of matter grew under gravity's influence, pulling gas together until the first stars ignited. Over billions of years, these stars gathered into galaxies, and galaxies merged into clusters. The cosmic web, a vast network of filaments stretching across space, is gravity's fingerprint on the universe itself. And yet, despite this grand reach, gravity does not act in isolation. It coexists with the other forces in a delicate hierarchy. The strong nuclear force binds protons and neutrons within atomic nuclei. The electromagnetic force holds atoms and molecules together. The weak nuclear force drives radioactive decay and powers processes in stars. Gravity, though feeblest among them, sets the stage on which all others operate. It provides the background geometry, the stage upon which the drama of matter and energy unfolds. Modern measurements of gravity continue to test Einstein's predictions with astonishing precision. The bending of light by galaxies, known as gravitational lensing, allows astronomers to map the distribution of invisible mass across the cosmos. Time dilation has been confirmed by comparing atomic clocks flown in aircraft to those on the ground. Even the slow in-spiral of binary pulsars, pairs of neutron stars orbiting each other, matches the energy loss predicted by gravitational wave emission. Every observation reaffirms that the universe behaves exactly as relativity foretells, and still, gravity hides its deepest secret. When we look into the heart of a black hole, or imagine the instant of the Big Bang, we reach a frontier where general relativity and quantum mechanics collide. The smooth curvature of spacetime predicted by Einstein meets the jittering uncertainty of quantum fields. At those scales, our equations break down. Some theories, such as string theory or loop quantum gravity, attempt to reconcile them, but none are proven. Until then, gravity remains the most familiar and yet most mysterious force in nature. It is easy to take gravity for granted because it never ceases. It anchors our bodies to the ground and gives weight to every object we touch. It turns falling water into power, keeps oceans on the planet, and makes every step possible. Yet behind that everyday experience lies a universal principle that governs everything from the smallest pebble to the most massive galaxy cluster. If we could somehow switch off gravity, even for the briefest instant, everything we know would begin to drift apart. The oceans would lift, the air would scatter, and the planet itself would come undone. Beyond Earth, the sun's core would stop fusing, the planets would leave their orbits, and the galaxies themselves would lose cohesion. This thought experiment is not about fantasy. It is a way of understanding just how inseparable gravity is from existence. Every atom, every heartbeat, every orbit, every passing second depends on it. Gravity is not simply a force. It is the geometry of being. But what if, against every law of physics, this curvature suddenly flattened and gravity vanished entirely? Then, the story of structure would end, and the story of disintegration would begin. Gravity is more than the thread that ties planets and stars together. It is the quiet rule that allows the universe to exist in a state of balance. Every second of our lives, this balance acts unnoticed beneath our feet, through our breath, and across the sky, above. Even the stability of time itself, the way seconds pass evenly, depends on the gentle curvature of space-time that gravity maintains. Without it, the very notion of up and down would dissolve into meaninglessness. The subtle strength of gravity lies in its persistence. Unlike electromagnetism, it cannot be shielded or cancelled. There is no such thing as negative mass to counteract it. Its pull may be weak between small objects, but when combined across vast distances and immense masses, it dominates the cosmic landscape. A star's gravity can bend light across millions of kilometers, while the collective attraction of galaxies determines the fate of the universe itself. Yet within our daily experience, this cosmic drama feels ordinary: the fall of a leaf, the arc of a thrown stone, the rhythm of ocean tides. Each is a whisper of the same universal geometry. Scientists have spent centuries trying to measure and describe gravity with increasing precision. From the delicate torsion balance experiments of Henry Cavendish in the 18th century to the space-borne observations of modern satellites, every attempt has revealed the same truth. Gravity is perfectly consistent. The value of the gravitational constant, though difficult to measure, underlies every equation that defines the motion of the cosmos. Even the most complex simulations of galactic evolution rely on that single number, determining how stars cluster, how planets form, and how black holes merge. Still, for all our measurements, gravity hides its origin. In the world of quantum physics, forces are often explained through the exchange of particles. Electromagnetism is carried by photons, the strong force by gluons, and the weak force by heavy bosons. Gravity, by analogy, would be mediated by a hypothetical particle called the graviton. But no experiment has ever detected it. At the scale of atoms, the influence of gravity is so faint that it is overwhelmed by every other interaction. The quantum description of space-time curvature remains incomplete, one of the greatest puzzles at the frontier of modern science. Some researchers look for answers in theories that extend beyond the familiar four dimensions of space-time. They suggest that gravity might be weak because part of its influence leaks into hidden dimensions curled tightly beyond our perception. Others explore loop quantum gravity, an approach that imagines space-time itself as composed of tiny, discrete loops of geometry. These ideas remain speculative, but they all share a single purpose: to understand why gravity behaves differently from the other forces of nature. Yet even without knowing its quantum nature, its macroscopic behavior, the way it bends light, slows time, and sculpts galaxies is confirmed with extraordinary precision. Consider what happens inside a black hole, where gravity grows so intense that not even light can escape. At its heart lies a region called the singularity, where density and curvature become infinite. General relativity predicts its existence, but cannot describe what truly occurs there. The laws of physics, as we know them, break down. It is a reminder that gravity, for all its familiarity, reaches beyond our comprehension. The same equations that describe the fall of an apple also predict these cosmic abysses, showing the unity of nature across all scales. On the opposite extreme, the faintest gravitational forces shape the slow ballet of galaxies across the observable universe. Over billions of years, clusters of galaxies drift, merge, and stretch under mutual attraction. Even the expansion of the universe, driven by dark energy, must contend with the countering pull of gravity. This interplay determines whether the cosmos will expand forever or one day contract. Though dark energy seems to be winning for now, gravity remains the constant sculptor, slowing expansion in places where matter gathers. From the curvature around a planet to the swirl of entire galaxies, the pattern is the same. Where there is mass, space-time bends. Where space-time bends, motion finds direction. This principle connects every scale of existence, from dust to stars, to the universe itself. It is a truth that every measurement, every telescope image, and every gravitational wave confirms anew. Yet perhaps the most humbling realization is that gravity also gives rise to the possibility of observers, beings capable of questioning the universe that birthed them. Without the stability gravity provides, planets could not exist long enough for life to form. The heavy elements forged in stars would scatter too quickly, never coalescing into the complex structures that make biology possible. In this sense, gravity is not only the architect of form, but the guardian of time, allowing the universe to persist long enough for consciousness to emerge. As we stand beneath the night sky, gazing at the faint light of stars hundreds of trillions of kilometers away, we are witnessing gravity's masterpiece. Every photon that reaches our eyes has followed a curved path, shaped by the invisible hand of space-time. The constellations that seem eternal are frozen moments in a universe where gravity's slow choreography unfolds over billions of years. And yet, all of it, the stars, the planets, the galaxies, depends on one simple principle: that mass and energy tell space-time how to curve. If, for any reason, that conversation were to cease, the entire structure of existence would begin to unravel. The orbits would straighten, the stars would cool, and even the flow of time would lose coherence. So imagine, for a moment, that the unimaginable happens. The invisible curvature that holds the universe together flattens, and gravity, the silent architect of reality, disappears. What follows is not merely the loss of weight or orbit, but the disassembly of existence itself. What happens in the first instant after gravity vanishes? The answer begins in the next chapter. As the universe forgets how to fall, the moment gravity disappears, the universe undergoes a transformation so complete that every law of motion begins to unravel. For a brief instant, there is silence, not the kind that comes from stillness, but the kind that follows the sudden end of an eternal rhythm. The curvature of space-time, the very geometry that guides the dance of worlds and stars, flattens to perfect emptiness. Every planet, moon, and atom continues along the path it was already moving, but now those paths no longer curve toward anything. In this unimaginable instant, Newton's first law takes over completely. Objects in motion continue in straight lines forever, and objects at rest remain at rest. There is no longer a central pull to hold an orbit, no downward acceleration to define weight, no curvature to give direction to falling. Every celestial body that once traced an elegant ellipse around its parent star now moves in a straight trajectory, tangential to the point where gravity vanished. The delicate balance between inertia and attraction that sustained orbits is broken. Every planet becomes a drifting traveler, continuing at the same velocity it had in that frozen moment. The Earth, once bound to the Sun by the curvature of spacetime, begins to travel straight into interstellar darkness. The Moon, freed from Earth's pull, drifts away along its own tangent, no longer circling its companion. The oceans, which once followed the curvature of the planet, begin to rise and disperse. The atmosphere, no longer anchored by weight, starts to thin as molecules float outward. Within seconds, the world becomes a cloud of matter, expanding in all directions, each particle obeying only inertia. Every orbit in the solar system disintegrates at once. The Sun no longer holds the planets, and the planets no longer hold their moons. Satellites that once followed precise paths now shoot off into the void. The entire solar system begins to unspool like a clock that has lost its gears. The balance that once made it a coherent system collapses into independent motion, each body preserving its final velocity but no longer bound to any other. Inside the Sun itself, catastrophe unfolds in microseconds. Its entire existence depends on the inward pressure of gravity compressing hydrogen into its core, maintaining the conditions for nuclear fusion. Without gravity's inward squeeze, the fusion reaction halts immediately. The tremendous outward radiation pressure that had balanced the inward pull suddenly has no opposition. The solar plasma begins to expand, cooling rapidly as it disperses. Within moments, the Sun's brilliant light fades, and what remains is an immense cloud of gas, moving outward at the speed of its last equilibrium. The star that gave life to our world dissolves into the darkness it once illuminated. Back on Earth, the disintegration continues. The surface, no longer held to a central core, fractures as the planet's rotation flings its matter outward. Rocks, oceans, and air separate into drifting streams of particles. The gravitational binding energy that once kept the planet spherical vanishes, releasing enormous stored potential. In mere seconds, Earth ceases to exist as a solid body. The fragments continue in straight lines, each moving at whatever speed rotation or orbital motion imparted. Some fragments drift outward into the emptiness that once was orbit. Others remain near, forming a chaotic, expanding cloud of debris. For living organisms, the loss of gravity is instantaneous and absolute. There is no sense of falling because there is no direction in which to fall. Every object not physically attached to something begins to drift away. The air itself no longer presses downward, so within moments, it expands, thinning to near nothing. Without atmospheric pressure, the gases that make breathing possible dissipate into space. The oceans lose their shape, rising in vast columns of mist and vapor before scattering. Every molecule follows its own inertial path, separating from every other. The disappearance of gravity also means the end of weight, but not the kind of weightlessness astronauts experience in orbit. In spaceflight, microgravity is the sensation of falling continuously around Earth, a balance between inertia and attraction. In this new, gravity-free universe, there is no fall at all. There is only drift. Nothing moves toward anything else. The sense of direction becomes meaningless because up and down no longer exist. In this first instant, the only remaining order is motion itself, velocity, trajectory, and momentum. Every body, from a pebble to a planet, retains the same speed and direction it had before gravity vanished. If Earth was traveling around the Sun at nearly 30 kilometers per second, it continues in a straight line at that same velocity. The Moon, moving at roughly 1 kilometer per second around Earth, now travels independently, no longer curved by the planet's mass. The entire architecture of orbital mechanics collapses into chaos governed by simple linear motion. Astronomers have often simulated what would happen if the Sun suddenly disappeared, using Newtonian equations to estimate the fate of the planets. The result is immediate. Each planet flies off tangentially to its orbit, traveling along a straight path through space. But even these models cannot capture the full catastrophe, because in our thought experiment, It is not just the sun's gravity that disappears, it is all gravity, everywhere. Every atom, every molecule, every star, every black hole loses its curvature, its attraction, its weight. Within a few moments of gravity's disappearance, the solar system is no longer a system at all. The sun's plasma continues to expand, cooling rapidly. The planets separate into clouds of debris, their fragments dispersing along linear paths. Space, once structured by orbits and tides, becomes a vast collection of isolated trajectories. The immediate consequence is not an explosion, but rather the end of cohesion. There are no more orbits, no more centers, no more balance points. The universe becomes an enormous field of motion without direction. The laws of inertia rule everything now, and nothing can bring matter together again. But the story of this unraveling does not end with the solar system. The loss of gravity ripples outward, reaching across the galaxy. Stars, too, depend on gravity for their shape, their fusion, and their light. As that force vanishes, the same disintegration that began with the sun begins on a galactic scale. The first instant of gravity's absence marks the beginning of the universe's dissolution. What once was ordered becomes chaos, and what once was curved becomes flat. And yet, to fully understand this transformation, we must trace the next steps to see what happens when the solar system itself comes undone. As the first second without gravity unfolds, the familiar harmony of the solar system dissolves into pure motion. The planets, which had been tracing elliptical paths around the sun for billions of years, now continue in straight lines, tangential to their former orbits. From afar, their trajectories would look like spokes shooting away from an invisible center, each one traveling at the exact velocity it had the moment gravity disappeared. Earth speeds outward at nearly 30 kilometers per second, while Mercury, once closest to the sun, races ahead at almost 50 kilometers per second. Jupiter and Saturn, farther from the vanished star, move more slowly, but their immense masses give them tremendous momentum. The solar system, once bound together by a single curvature of spacetime, becomes a scattering of worlds drifting into darkness. Within the first few minutes, the distances between the planets grow at astonishing rates. Without the sun's pull, there is no common orbit to hold them in formation. Earth's path takes it away from the region where sunlight once shone. Even if the sun's light had not vanished along with its gravitational field, that light would never reach Earth again, because the planet is now moving away at a constant velocity, with no force to turn it back. In the emptiness ahead, there is only darkness and silence, the faint echo of the last photons emitted before fusion ceased. The moon's separation from Earth is immediate. Freed from its orbit, it continues along its own tangent, traveling roughly 1 kilometer per second, relative to the position it once circled. In just a few hours, the distance between the two bodies grows by tens of thousands of kilometers. The gravitational relationship that once caused tides, eclipses, and the rhythmic pull of the oceans is gone forever. The pair that had shared motion for 4.5 billion years is now drifting apart, never to meet again. Earth itself, though still holding together for the briefest moment, due to internal cohesion, cannot remain stable. The planet's shape was determined by hydrostatic equilibrium, the inward pull of gravity balanced by the pressure of the materials within. Remove that inward pull, and the forces maintaining this balance lose direction. The molten core begins to expand, the crust fractures, and the oceans lift from their basins, forming colossal plumes of vapor. The atmosphere, once dense enough to scatter blue light and shield life, expands rapidly into space. Within seconds, air pressure drops to near zero. To a human observer, the change would be instantaneous and fatal. There would be no sensation of falling or flying, only disorientation, as every object begins to float and drift away. Buildings separate from their foundations, oceans rise as clouds of mist, and the sky ceases to have meaning because there is no longer an up or down, The force that gave direction to every step and every breath is gone. Beyond Earth, smaller bodies like asteroids and comets follow their own straight paths. The asteroid belt, once circling the Sun between Mars and Jupiter, disperses outward in all directions. Each fragment maintains its previous speed and orientation, spreading across the galaxy like a cloud of dust. The Kuiper belt, home to countless icy objects beyond Neptune, also disintegrates, its components moving outward along trajectories that will never intersect again. For a brief time, these bodies continue to reflect the last light from the dying Sunday. But as the solar plasma expands and cools, that light fades into infrared glow, then into nothing. The solar system's once brilliant center becomes a diffuse cloud of hydrogen and helium, no longer a source of warmth or illumination. Spacecraft and satellites, too, lose their orbits instantly. The International Space Station, once falling endlessly around Earth, now moves in a straight line tangent to its previous path. Its velocity carries it away from the disintegrating planet, still at roughly 7 kilometers per second. Probes sent to the outer planets drift onward forever, continuing along their final trajectories, never slowing, never turning. Every man-made object in orbit becomes a wanderer, just like the planets themselves. Within hours, the structure of the solar system ceases to exist. What was once a family of worlds orbiting a star becomes a diffuse cluster of fragments, each traveling outward through space, never to return. There are no more gravitational centers, no more orbits, no more systems of any kind. To describe this transformation accurately, physicists use the principles of conservation of momentum and energy. When gravity vanishes, there is no external force acting on any body. Thus, each object's momentum, its mass, multiplied by its velocity, remains constant. The total energy of motion in the system is preserved, but redistributed into straight-line motion rather than curved orbits. The planet's velocities become eternal, unchanging, and uncorrelated. Over longer timescales, these trajectories would carry the fragments of the former solar system deep into interstellar space. After 1 year, Earth would be more than 900 billion kilometers away from where the Sun once burned. After 10,000 years, it would have traveled far beyond the boundaries of the Milky Way's local spiral arm, continuing endlessly into the galactic void. Every other planet, moon, and asteroid follows the same fate, moving in silent parallel through an ever-darkening expanse. What remains behind is emptiness, a region of space that once contained a solar system, now filled only with thin traces of cooling plasma and the faint afterglow of scattered radiation. The geometry of spacetime in this region, once curved by the Sun's mass, is now flat. It no longer guides motion, it merely hosts it. This flattening of geometry is not a collapse, but an erasure of structure. In Einstein's picture, spacetime without mass is not destroyed. It simply becomes uniform. Without curvature, it has no hills or valleys, no guidance for motion. The planets and fragments do not fall into the void. They coast through it without direction, like ships sailing across a featureless sea with no currents and no horizon. In the following hours, as the solar remnants drift farther apart, even light itself loses its familiar paths. There are no more gravitational lenses, no bending of starlight, no tidal stretching of space. The Sun's photons, released before its death, continue outward in straight lines, spreading across an infinite darkness that will never echo them back. And thus, within mere hours of gravity's disappearance, the solar system, that intricate clockwork of orbits and balances, ceases to exist as a coherent structure. All that remains are fragments of motion, traces of what was once order, now scattered in perfect linearity. But the loss of gravity does not stop here. The same laws that unbound the solar system now begin to act on larger scales. Stars within the Milky Way, once held together by the combined curvature of spacetime, start to drift apart. The galaxy itself begins to dissolve. To grasp what happens next, we must look beyond our small corner of the cosmos to the collapse of structure across the galactic scale. In the hours that follow the solar system's collapse, the effects of gravity's disappearance begin to spread through the Milky Way. Every star, Every cloud of gas, every dark matter halo that once moved in a graceful orbital balance now begins to drift freely. The great spiral pattern of the galaxy, which had taken billions of years to form, starts to unravel as each star continues along its last known trajectory. The familiar structure of the Milky Way, its spiral arms, its dense core, its halo of orbiting globular clusters, dissolves into a slow, chaotic scattering of light. Under normal conditions, the stars in the Milky Way are held together by the combined gravitational attraction of all their masses. Each star follows an orbit around the galactic center, just as the planets orbit the Sunday. These orbits are stable because the inward curvature of spacetime, produced by the galaxy's total mass, balances the outward tendency of motion. When that curvature disappears, there is nothing to keep the stars in their tracks. Every one of the roughly 400 billion stars continues in the direction it was already moving, at speeds ranging from tens to hundreds of kilometers per second. The result is a slow-motion explosion, on a scale so vast that even light cannot cross its full breadth in a human lifetime. The stars do not collide or shatter, they simply drift apart. Over the next few thousand years, the Milky Way loses its shape completely. From afar, it would appear as a cloud of scattered points expanding through the void. The bright central bulge fades as its dense clusters of stars disperse, and the once shining spiral arms dissolve into streaks of faint light stretching across intergalactic space. This process continues outward, affecting every galaxy in the universe simultaneously. The gravitational connections that bound galaxies into clusters are broken. The massive conglomerations of thousands of galaxies, which once moved in slow, mutual orbits, now disperse. Their trajectories, once guided by the invisible scaffolding of dark matter, become simple straight lines through spacetime. Dark matter itself, which interacts only through gravity, loses its ability to form structures. For the first time since the universe began, the dark matter halos that gave galaxies their mass and shape evaporate into uniform motion. There is no more clustering, no more filamentary structure forming the cosmic web. The universe begins to look like a mist of particles spread evenly across infinite emptiness, each one following its last direction forever. The sudden disappearance of gravity also brings an end to the possibility of star formation. Normally, gas clouds collapse under their own weight, compressing until their centers become hot and dense enough to ignite nuclear fusion. Without gravity, no such collapse can occur. Every cloud of hydrogen and helium now disperses into the void, never again to form a star. The lights already burning will soon fade, and no new ones will ever replace them. The same applies to remnants like neutron stars and black holes. Neutron stars exist because gravity compresses matter so tightly that protons and electrons merge into neutrons. Without gravity, the pressure maintaining this state disappears instantly. The neutrons separate back into their constituent particles, releasing bursts of radiation before scattering into nothingness. Black holes, whose defining feature is the curvature of spacetime so extreme that not even light can escape, cease to exist the moment curvature itself vanishes. Their singularities evaporate not through Hawking radiation, but through the simple erasure of geometry. There is no longer an event horizon, because there is no longer any bend in spacetime to define one. If we could observe this event from outside time, we would see the universe flattening in a wave of release. The curvature that once shaped the cosmos smooths out, leaving behind a field where distance and direction have no special meaning. Objects continue moving, but the relationships between them, the orbits, accelerations, and centers of mass are gone. What remains is pure inertia. For civilizations that once observed the night sky, the loss of gravity would mean the end of navigation, of astronomy, of any recognizable cosmos. The constellations would stretch and distort as their stars drifted apart, and within years, no familiar pattern would remain. Every star's motion would be unchanging and straight, so the night sky would never again exhibit the slow, cyclical changes that guided calendars and science. It would instead become a scattering of dim points, thinning as distances increased, until no star was bright enough to see. At the galactic center, where a supermassive black hole once anchored the Milky Way, the consequences are even more profound. Sagittarius A star, a black hole of roughly 4 million solar masses, disappears as the curvature sustaining it vanishes. The dense cluster of stars orbiting around it, freed from its grip, fly outward at their previous velocities. The central region, once the brightest in the infrared spectrum, fades into emptiness. Over the next million years, the disintegration of the Milky Way becomes complete. The stars that once formed its glowing band across the sky are now separated by distances so great that they no longer form a coherent shape. The galaxy becomes an expanding sphere of isolated stars, each carrying with it the remnants of any planets or debris that once orbited them. Beyond that timescale, even these stars will cool and fade. Without gravity, time itself becomes uniform. There are no more regions where it slows near massive bodies, no gravitational redshift or blue shift of light. Every photon travels in a straight line through flat spacetime. The universe becomes static, featureless, and empty, with all motion proceeding endlessly but meaninglessly. The first instant of gravity's disappearance has become the final state of matter, pure momentum without interaction. The solar system's collapse was only the beginning. The Milky Way's dissolution marks the loss of structure itself. But to understand what this means for the deeper layers of reality, for the quantum fields, and the atomic fabric that still remain, we must go smaller. For even though the stars and planets are gone, the atoms themselves still exist. The electromagnetic and nuclear forces endure, holding matter together even when gravity has vanished. And it is within these remaining forces that the final remnants of order continue to flicker, resisting the absolute stillness that now rules the cosmos. The disappearance of gravity has transformed the solar system into an expanding chaos of motion. But to truly understand the scale of this transformation, we must look more closely at what happens in the seconds, minutes, and hours that follow. For billions of years, the Sun and its planets existed in a delicate balance of attraction and momentum. The inward curvature of space-time, created by the Sun's immense mass, constantly guided the planets into their repeating elliptical orbits. Remove that curvature, and all of that order disintegrates in an instant. At the very center of this catastrophe is the Sun itself. Before gravity vanished, its existence depended on equilibrium. The crushing inward pull of its mass balanced the outward pressure of nuclear fusion. That balance, called hydrostatic equilibrium, was precise to the smallest degree. The temperature at the core reached nearly 15 million degrees Celsius, allowing hydrogen atoms to fuse into helium and release the energy that made sunlight. But without gravity's inward compression, that equilibrium vanishes. The Sun's core, suddenly unconfined, expands violently. In the first fraction of a second, fusion stops. There is no longer any pressure to keep the nuclei close enough to collide. The immense heat trapped in the core begins to dissipate as the plasma expands. The light that once streamed outward from the photosphere fades rapidly, because energy is no longer being replenished. Within minutes, the Sun's luminosity drops from a blinding brilliance to a dull red glow. Its outer layers billow outward like smoke in a vacuum, cooling as they spread. The particles that once formed the Sun's structure now follow their own linear trajectories, continuing in whatever direction they were moving at the instant. Gravity vanished. Since there is no longer any central attraction, these particles never return. The Sun, once a blazing sphere of fusion, becomes an expanding cloud of ionized gas, moving through the darkness. Its light, fading into infrared and then into the invisible, becomes one last echo of its former brilliance. As the Sun's core disperses, its electromagnetic field weakens and stretches. The heliosphere, the bubble of charged particles and magnetic fields that once enveloped the solar system, collapses. Without the solar wind, the boundary that shielded the planets from cosmic radiation disappears. But there are no longer any intact planets to be shielded. Each one is already breaking apart, its materials scattered by rotational inertia and thermal expansion. Earth, Mars, Venus, and the other terrestrial planets begin to unravel differently depending on their composition. Earth's iron core expands first, its internal pressure releasing as gravity's confining hand disappears. The crust fractures into thousands of pieces, while the mantle below boils upward in plumes of molten rock. The oceans, unbound from the surface, lift as vapor into the thinning atmosphere, then disperse into space. Within minutes, the blue planet that once teemed with life becomes a cloud of rock, steam, and metal, expanding outward from its former orbit. Gas giants like Jupiter and Saturn undergo an even more dramatic transformation. These worlds were composed mostly of hydrogen and helium, held together by their own immense gravity. Without that binding force, they expand explosively. Their dense cores rupture, and their outer layers inflate into vast, diffuse spheres that merge with the expanding remnants of the sunday. For a short time, the region of space that was once the inner solar system becomes filled with glowing clouds of gas, still illuminated by the last fading radiation from the dying star. But this glow is brief. As the gases expand, they cool, and the light fades into infrared shadows. Further out, Uranus and Neptune dissolve more slowly. Their icy atmospheres of methane and ammonia expand into the vacuum, forming translucent veils of vapor. The frozen objects of the Kuiper Belt follow the same fate. Comets, which once traced long elliptical paths around the Sun, lose their orbits entirely. Their icy nuclei fragment and drift outward in straight lines, forming faint trails that stretch for billions of kilometers. In a matter of hours, what was once the solar system becomes an expanding sphere of dust, gas, and broken rock, spreading at thousands of kilometers per second. No fragment ever turns back, because there is no force to bend its path. The geometry of spacetime itself has become flat, removing every curve that once guided motion. If we could observe this scene from a distant point in space, we would see a faint, growing cloud where the sun once burned. The bright center fades into a dull glow, surrounded by expanding rings of vapor and dust. Each planet's debris moves outward in a different direction, tracing the last motion it had before the collapse. The paths never intersect, because without gravity, there is no tendency for matter to collect or collide. The solar system's final state is one of perfect dispersal. In this new universe, there are no orbits and no centers. The very concept of a system has lost its meaning. Each fragment of matter now moves independently, its motion determined only by the momentum it carried before gravity disappeared. Momentum and energy are conserved, but structure is gone. The planets, the sun, and the countless small bodies that once danced in balance have become participants in a single, silent exodus from the center that no longer exists. And yet, the disintegration of the solar system is only the beginning of a far greater unraveling. The same forces that once held the stars together in galaxies are gone, and the consequences reach far beyond our local neighborhood. For now, the expanding remnants of the solar system drift quietly through the emptiness, their atoms still bound by electromagnetic and nuclear forces. But without the gravitational bond that once defined their paths, the solar system has ceased to exist. It has become a cloud of memory, a faint, expanding trace of what was once a world. The next step in this cosmic disassembly will not concern only the sun and its planets, but the entire structure of the galaxy itself. For gravity was the glue not only of worlds, but of stars, and without it, even the Milky Way will dissolve into darkness. In the silent void where the solar system once revolved, motion becomes the only remnant of order. The fragments of planets, moons, and asteroids now travel along perfectly straight lines, never bending, never slowing, never meeting again. Each grain of dust that was once part of a mountain, each molecule that once floated in an ocean breeze, now drifts endlessly through space. The solar system's history, 4.5 billion years of evolution, has ended in a single instant of release. At first, the expanding cloud of debris still resembles a faint sphere centered around the position the Sun once occupied. But as time passes, the different velocities of its countless fragments stretch it into a diffuse, irregular shape. The smallest particles, pushed outward by the pressure of escaping gas, move faster than the heavier fragments. Within days, the inner solar system becomes a tenuous haze of atoms and dust. There is no more sunlight, no warmth, and no structure. Thermodynamics continues to rule what little remains. When the Sun's gravitational compression ceased, the energy trapped in its core began to escape as heat and radiation. That energy now spreads freely through space, cooling rapidly as it expands. The gases that once glowed at thousands of degrees drop toward the background temperature of the cosmos, just a few degrees above absolute zero. The entire system is losing entropy's battle in reverse. Instead of gathering into complex forms, it is dissolving into uniformity. The same process occurs with every planet. When gravity disappeared, the potential energy stored in their structures converted into kinetic energy and heat. The crusts shattered, the cores expanded, and their materials scattered outward. As this matter continues to drift, collisions between fragments become exceedingly rare. The distances between them grow too vast for any meaningful interaction. In the absence of gravity, there are no longer orbits to cross or centers to approach. Each piece of matter follows a solitary path, unaware of any other. The laws of conservation still hold, but they no longer produce complexity. Total momentum remains constant. Total energy remains constant, but there is no longer a mechanism to concentrate or transform it. Without gravitational compression, there can be no fusion, no starbirth, no recycling of matter. The solar system's elements, iron, silicon, carbon, oxygen, remain scattered as isolated atoms or small aggregates. The carbon that once built living cells now drifts alongside the silicon that once formed rock, and both are equally without purpose. On longer timescales, these fragments begin to spread over astonishing distances. After 1 year, the expanding remnants of the solar system span a volume billions of kilometers across. After 1,000 years, they have stretched across a region so large that even light would take weeks to cross it. To any distant observer, the area that once contained the Sun and planets now appears completely dark, with only a faint infrared glow betraying the presence of residual heat. Even the electromagnetic fields that once defined the solar system's boundaries are fading. The Sun's magnetic field, which once shaped the flow of solar wind and protected the inner planets, decays as its plasma cools. The Earth's magnetic field, generated by its molten iron core, vanishes the moment that core stops spinning as a coherent mass. The invisible magnetic envelopes that once shielded life from radiation dissolve into background noise. Without gravity, there are no more gravitational waves, no tidal forces, no orbital resonances. The universe becomes quiet in a way that transcends sound quiet in the motion of geometry itself. There are no oscillations in spacetime, no ripples carrying information across the cosmos. What remains is an absolute stillness of curvature, a universe where space is perfectly flat and unresponsive. In the absence of curvature, the notion of direction itself becomes fragile. Every motion is relative, but there is no reference point by which to measure it. The idea of a center has vanished completely. The solar system's former heart, the position once occupied by the Sun, has no meaning anymore. There is no gravity well, no basin in space-time, no coordinate that marks a special place. Everything is equivalent. Everything is empty. To imagine the aftermath is to imagine a universe without boundaries. The fragments of the planets, the dust of the Sun, and the vapor of oceans now drift through flat space-time that stretches infinitely in every direction. Their inertia will carry them forever, unless another force, electromagnetic or nuclear, acts upon them. But those forces are short-ranged, binding only within atoms or molecules. On cosmic scales, they are powerless to reunite what gravity once held. If we could watch the solar system's ruins over millions of years, we would see the expanding debris become indistinguishable from the interstellar medium. The materials that once formed planets and stars would blend into the faint gas that fills the space between galaxies. But unlike the real universe, where gravity eventually gathers this gas into new generations of stars, here there will be no second act. The cycle of creation has been broken permanently. The loss of the solar system's structure also means the loss of time as we perceive it. On Earth, the passage of time was defined by cycles: rotation, orbit, day, night, and season. Without those cycles, time continues to flow uniformly, unmeasured and unbroken. There are no more shadows to mark the sun's position, no planetary motion to define years. In this gravity-free universe, time has become an abstraction, existing only as a parameter of motion, not as an experience of change. Yet, amid this emptiness, one truth remains. The smaller forces of nature still endure. The electromagnetic force continues to bind electrons to nuclei, ensuring that atoms still exist. The strong nuclear force still holds the protons and neutrons together inside atomic cores. The weak force still governs radioactive decay. On these microscopic scales, the absence of gravity changes nothing. The fundamental particles continue their subtle interactions, preserving the last traces of physical law in an otherwise lawless cosmos. But the great architectures that once emerged from those interactions, the stars, the planets, and the galaxies are gone. The solar system has not merely been destroyed, it has been erased from the framework that gave it meaning. All that remains are isolated atoms moving endlessly through space-time, obeying laws that can no longer build structure. The next stage of this story belongs not to the solar system, but to the galaxy that once contained it. For while our small corner of the universe has already dissolved, the Milky Way itself is beginning to lose cohesion. Its hundreds of billions of stars are now drifting apart, and its vast gravitational heart, the core that once held them together, is unraveling. And so the disintegration continues, outward from the scale of planets to the scale of galaxies. What began as a local catastrophe becomes a universal one, as the absence of gravity begins to unmake the very structure of the cosmos itself. In the deep quiet that follows the destruction of the solar system, motion itself becomes the only remaining signature of existence. Each atom, rock, and dust particle continues on an unbending line, locked forever into the inertia it carried when gravity vanished. There are no collisions to slow them, no fields to gather them, no centers to fall toward. The universe has lost its great organizer. All that remains of the once living solar system is a shell of fragments dispersing endlessly into a silence so vast that no sound, no light, and no meaning can echo within it. As years pass, the memory of the solar system fades into the background of an expanding void. Earth's fragments drift thousands of billions of kilometers away, their velocities unchanged. The remnants of the sun, now a thin gas of cooling ions, spread until they are indistinguishable from interstellar dust. Once, the solar system's gravity provided an anchor, a local region of structure in a sea of stars. Without that anchor, its debris merges into the galactic flow, though that too is beginning to unravel. The forces that once gave the Milky Way its spiral form are weakening everywhere, not because they have diminished, but because they no longer exist. The thermodynamic story of this disintegration continues without pause. Energy once confined by gravity now disperses freely. The kinetic energy of expanding gases spreads across ever greater volumes of space, lowering temperature toward absolute zero. There is no longer any compression, no conversion of heat into fusion, and no potential wells in which energy can accumulate. Entropy, the measure of disorder, approaches its theoretical maximum. Every system moves toward perfect uniformity, a universe with no gradients, no flows, and no direction of change. If one could somehow observe the region that once contained the solar system from afar, it would appear as a diffuse, cold cloud, expanding into nothingness. There would be no boundary where one could say the solar system ended and interstellar space began. The two have become one. Even light, once reflected from the surfaces of planets, fades as photons travel unimpeded into infinite flat space-time. The background grows darker than darkness itself, because there is no longer any contrast, no longer any curvature, to guide the path of light into patterns we might recognize as form. Yet within the microscopic realm, stability remains. Atoms continue to exist, for their integrity does not depend on gravity, but on the far stronger electromagnetic and nuclear forces. The electrons remain bound to their nuclei, and the atomic shells still hum with quantum motion. If we were to isolate a single atom from the wreckage of Earth, we would find its inner structure unchanged, a tiny island of order within infinite desolation. But these atoms no longer have any collective purpose. They do not assemble into molecules, nor combine into matter of larger scale. The temperature and density are too low, and collisions too rare for chemistry to persist. Matter, once dynamic and creative, has become inert. Over millions of years, the remnants of the solar system spread across such vast distances that they are effectively erased. The cloud becomes so diffuse that no observer could distinguish it from the general interstellar medium. The heavy elements forged in the sun's core, iron, carbon, oxygen, once destined to form future planets, now drift alone, never to condense again. The cycle of star birth and death that characterized the living universe is broken forever. This diffusion marks a profound thermodynamic turning point. In the real universe, gravity drives entropy by forming stars and galaxies, paradoxically creating order from collapse. But in a universe without gravity, entropy becomes static. The expansion continues, but nothing new emerges. The universe approaches a thermal equilibrium where energy and matter are evenly distributed, and every process that depends on gradients from fusion to motion ceases to exist. Even time itself loses its texture. Time, in the presence of gravity, flows differently near massive bodies. It stretches and compresses, giving the universe rhythm. Without those curvatures, time becomes flat and uniform. There are no longer regions of slower or faster flow, no gravitational redshift to stretch light, no black holes to warp the sequence of events. Time continues, but it no longer marks change. It becomes an empty parameter, describing the eternal stillness of flat space-time. The final traces of the solar system linger only as motion through that stillness. The fragments of planets continue outward at the same speeds, but in a universe where motion has no consequence, even velocity loses meaning. With no reference frame, no curvature, and no interaction, every direction is the same. Motion without relation is indistinguishable from rest. The universe becomes a paradox of infinite movement and perfect stillness, a cosmic field of trajectories that never intersect and never end. What was once the solar system, a symphony of orbital motion, radiation, and gravitational balance, is now a silent equilibrium. The physical laws still exist, but they have no stage upon which to act. The atoms persist, but the forces that once sculpted their arrangements into planets and life have ceased. The story of structure has ended, leaving behind only the pure abstraction of motion. Yet this dissolution, as immense as it seems, is only one fragment of the greater collapse taking place. Across the galaxy, the same fate is unfolding simultaneously. The Milky Way, once a vast spiral of hundreds of billions of stars, is disassembling just as completely as the solar system. Its stars, no longer guided by the gentle curvature of space-time, are moving away from one another, following their last linear velocities into the deep intergalactic void. And so, from the death of one star to the fading of an entire galaxy, the same pattern repeats, the universe unwinding into emptiness. The next stage of this cosmic unraveling lies not within the scattered remnants of a single system, but across the grand scale of galactic structure itself, where the very architecture of the cosmos begins to fade. Across the universe, gravity's sudden absence sends a silent, unstoppable wave of disintegration through the fabric of cosmic architecture. What began with the collapse of planetary systems now reaches the scale of galaxies themselves. For billions of years, galaxies have been the universe's great monuments of structure, vast collections of stars, gas, dust, and dark matter bound together in the slow dance of gravitational attraction. With that binding force erased, the Milky Way, and every galaxy like it, begins to fall apart, not into chaos, but into motion without return. In the first moments after gravity vanishes, the stars of the Milky Way continue along the orbits they had been following. Each star, from the smallest red dwarf to the most massive blue giant, moves tangentially away from the galactic center, following its last trajectory in straight, unbent lines. The familiar spiral arms, which had been sculpted by density waves moving through the galaxy's disk, lose coherence. They begin to stretch outward, unraveling like threads pulled from a vast, rotating tapestry. At the center of the Milky Way, the supermassive black hole that once anchored everything disappears instantly. Without space-time curvature, there is no event horizon, no gravitational singularity, no force pulling the stars inward. The millions of stars that once orbited the galactic core, some at thousands of kilometers per second, now continue freely into space, spreading outward in all directions. The dense nucleus of the galaxy, once glowing with the combined light of countless suns, dissolves into an expanding void. The same process repeats throughout the galactic disk. The stars were held together by their mutual attraction and by the enormous dark matter halo surrounding the galaxy. But dark matter interacts only through gravity. When gravity vanishes, so too does its influence. The invisible framework that gave galaxies their mass and motion evaporates, leaving the luminous stars to drift apart. Over the next few thousand years, the structure of the Milky Way becomes unrecognizable. The spiral pattern disappears completely, replaced by a diffuse haze of stars moving away from one another. No collisions occur, the distances between stars are simply too vast, but the sense of organization is gone. From afar, what was once a spiral galaxy now resembles a faint, expanding cloud of light, each star traveling forever along its final path. The interstellar gas that filled the Milky Way behaves differently. Before, the gas was drawn into dense molecular clouds by gravity, forming the nurseries of new stars. Now, those clouds expand freely, their atoms dispersing into the emptiness between stars. No new stars will ever form. The great cycle of stellar birth and death, the engine that recycles elements and fuels galactic evolution, comes to a permanent stop. The universe has entered an irreversible state of dispersal. Even the faintest remnants of gravitational influence vanish from large scales. Galaxy clusters, which once contained hundreds or thousands of galaxies orbiting their common center of mass, lose cohesion. Each galaxy continues on its linear trajectory, leaving the cluster behind. The large-scale filaments of the cosmic web, those vast, interconnected structures of galaxies and dark matter, dissolve. The universe's intricate pattern of clusters, filaments, and voids smooths into a uniform distribution of drifting matter. Without gravity, the concept of a galaxy ceases to have meaning. The Milky Way's name once described a system held together by a common curvature of space-time. Now, it is only a memory, a region of once associated stars moving independently through the void. Every other galaxy across the cosmos follows the same fate. The Andromeda Galaxy, which in reality is moving toward the Milky Way and would have merged with it in several billion years, now passes by unnoticed, its stars continuing straight ahead without attraction or collision. This unraveling has profound consequences for light itself. In the real universe, light bends around massive objects, producing phenomena like gravitational lensing, the magnification of distant galaxies by the curvature of spacetime near closer ones. But in this flat, gravityless cosmos, light travels in perfect straight lines. There are no lenses, no distortions, no arcs of magnified light around clusters. Every photon moves uniformly, unaltered by any curvature. The beauty of the gravitationally shaped cosmos, the halos, rings, and arcs, seen in deep field images, is gone. Thermodynamics now dictates the fate of energy on a galactic scale. Without gravitational compression, there are no mechanisms for generating heat beyond local atomic collisions. The stars, each now isolated, continue to radiate their remaining energy into the cold void. But as they drift apart, their light spreads thin. Over millions of years, the space between them becomes so vast that their light no longer overlaps. Each star becomes a solitary beacon, its photons traveling endlessly, never reaching another star, planet, or observer. In this gravity-free universe, entropy's role is absolute. The process of structure formation that once defined cosmic history, from gas clouds collapsing into stars, to stars forming galaxies, to galaxies merging into clusters, reverses permanently. Order decays into uniformity. The distribution of matter approaches perfect homogeneity, with no forces left to disturb it. The universe's geometry has become Euclidean again, flat, infinite, and inert. For the few moments that stars still burn, the universe remains faintly illuminated, but their light, too, will fade. As fusion ends in their cores, the remnants expand, cool, and disperse. White dwarfs, neutron stars, and black holes no longer exist because their defining gravity-dependent properties have vanished. What remains are clouds of atoms, expanding endlessly. If one were to describe this transformation mathematically, it would appear simple. The gravitational term in Einstein's field equations has been erased. The curvature tensor becomes zero everywhere, and spacetime is flat. Energy still exists, but without curvature, it cannot influence geometry. The universe has become an inert continuum of energy and matter, disconnected and static. The disappearance of gravity also means the disappearance of acceleration. Without curvature, there are no longer any preferred frames of motion. Everything moves uniformly, so relative velocity becomes the only remaining description of change. The Milky Way's former stars, hundreds of billions of them, continue on their inertial paths, but their trajectories no longer define orbits, spirals, or any kind of collective pattern. In time, even the concept of galactic time loses meaning. Galaxies, as coherent entities, no longer exist to mark epochs or measure evolution. The universe has entered a state of eternal expansion, without formation, a stillness within motion. The galaxies that once defined the cosmic story have dissolved into an infinite, undifferentiated mist. And yet, even now, deeper consequences are unfolding, not in the vastness of galaxies, but within the smallest scales of matter itself. The gravitational collapse of the large has ended, but the microscopic world remains governed by the electromagnetic, strong, and weak interactions. What happens to these fundamental domains when gravity, the architect of scale and curvature, no longer exists to unify them within spacetime? The next chapter will descend into that quantum realm where matter still clings to its identity even as the universe itself falls apart. Even though galaxies and stars have come apart, the disappearance of gravity does not mean the end of all matter. Gravity is the weakest of the four known fundamental interactions, and the other three, the electromagnetic, the strong, and the weak forces, still endure. These remaining forces continue to operate within atoms and subatomic particles, binding them in ways that gravity never could. While the cosmic structures built by gravity collapse into uniformity, the microscopic world remains intact. The laws of quantum mechanics persist, untouched by the loss of curvature on cosmic scales. At the atomic level, almost nothing changes. Gravity plays no significant role in the stability of atoms or molecules, Its influence there is so small that it can be ignored, even under normal conditions. Electrons remain bound to their nuclei by the electromagnetic force, which is roughly 10 to the power of 39 times stronger than gravity at atomic distances. The protons and neutrons within each nucleus remain locked together by the strong nuclear force, a power that overcomes even the repulsion of their positive charges. Even the weak nuclear force continues its subtle work of transforming one type of particle into another through radioactive decay. In this gravityless universe, therefore, matter itself does not dissolve. A hydrogen atom is still a hydrogen atom. The quantum fields that define the behavior of fundamental particles, electrons, quarks, neutrinos, and photons, continue their dance according to the same rules that have governed them since the birth of the cosmos. Space may be flat, but the underlying quantum fields that fill it still fluctuate. Virtual particles still appear and vanish in fleeting moments, preserving the restless texture of the quantum vacuum. But while atoms persist, the loss of gravity alters the large-scale relationships between them. Normally, gravity sets the stage upon which quantum mechanics plays out, giving physical meaning to space, distance, and curvature. With no curvature, space-time becomes a perfectly flat continuum, and the concept of location loses its absolute meaning. The quantum fields now extend uniformly, with no preferred points or gradients. Matter remains, but it exists in a universe without shape, a sea of particles suspended in featureless flatness. In a strange way, the loss of gravity has purified the laws of physics. The quantum fields operate in their simplest form, uncurved and unperturbed by large-scale structure. Every photon, electron, and proton follows its own path through space-time without deviation. The electromagnetic field continues to propagate at the speed of light, defining interactions between charges. The strong and weak forces continue to operate only within the confines of atomic nuclei. The mathematics of quantum electrodynamics and quantum chromodynamics remain valid, describing perfectly the behavior of the small, even as the large dissolves. Yet gravity's disappearance has profound implications for certain extreme forms of matter. Neutron stars and black holes, which depend entirely on gravitational compression, cease to exist. A neutron star exists because gravity compresses atoms so tightly that electrons and protons combine into neutrons, forming a single atomic nucleus the size of a city. Without gravity, the forces that hold this ultra-dense matter together vanish instantly. The neutrons separate, expanding outward in a burst of energy as the star's matter returns to ordinary atomic density. For black holes, the situation is even more dramatic. A black hole is not truly an object, but a region of space-time where gravity's curvature becomes infinite. It is defined by an event horizon, the boundary beyond which nothing, not even light, can escape. The moment curvature ceases to exist, so too does that boundary. The event horizon dissolves, releasing everything that had been trapped within. The singularity at its center, a point of infinite density, vanishes as well, because density itself has no meaning without curvature to define volume. Whatever particles and radiation once orbited within the horizon now expand freely into flat spacetime, their confinement suddenly erased. These collapses are not explosions in the ordinary sense. They are the release of confinement rather than the transfer of energy. A neutron star does not detonate, it simply expands, its matter returning to ordinary atomic spacing. A black hole does not burst, it ceases to exist, leaving behind a sphere of radiation and high-energy particles dispersing outward. The vast energies associated with these transitions would briefly fill the universe with a flash of radiation, but that light, too, would fade as it expands through the now infinite, uncurved void. The existence of matter without gravity raises deep questions about the nature of space-time itself. In general relativity, matter and energy are inseparable from geometry. They tell space-time how to curve, and curvature tells matter how to move. If curvature is gone but matter remains, then this relationship has been broken. The universe now hosts energy without geometry, motion without direction, and particles without mass in the gravitational sense. Mass, as we understand it, is not merely a measure of substance, it is the source of curvature. In the absence of gravity, the concept of inertial mass still exists, but it is purely a property of resistance to acceleration, not a cause of attraction. Every particle retains its inertial mass, obeying Newton's first law, but its gravitational mass, its ability to curve space-time, has vanished. The equivalence principle, one of Einstein's cornerstones, no longer applies. Matter still moves, but its motion no longer defines geometry. Quantum field theory continues to describe the vacuum with exquisite precision. The Higgs field, which endows particles with mass through interaction, remains unchanged. It gives electrons and quarks their inertial masses just as before. But without gravity, those masses have no large-scale consequence. The Higgs field provides inertia, but no curvature responds to it. Matter, therefore, becomes self-contained, still following the equations of motion, still capable of electromagnetic and nuclear interactions, but isolated forever in the flat expanse of space-time. In this new universe, the atomic and subatomic world remains the only domain where structure survives. Atoms continue to exist in a stable, eternal equilibrium. But without gravity, there is no pressure to bring atoms together into planets or stars, and no cooling to form complex structures. Chemistry still functions, but only locally and fleetingly. Molecules can still form if particles collide by chance, but such collisions become vanishingly rare as matter spreads across infinite flatness. Thus, while gravity's absence does not annihilate matter, it erases the context that gave matter its meaning. The forces that remain are confined to microscopic scales. They bind particles into atoms, but they cannot bind atoms into worlds. The cosmos has become a mosaic of isolated quantum islands, drifting through infinite, uncurved emptiness. And yet, even here, at the smallest scales, gravity's absence hints at something profound, for the laws of quantum physics were never fully unified with those of gravity. Without curvature, the two domains no longer need to coexist. The universe has split cleanly into two halves: the quantum, which endures, and the geometric, which has vanished. But how long can matter persist in such isolation? Without gravitational wells to define temperature gradients or time dilation, the universe moves toward perfect equilibrium. Over vast timescales, quantum fluctuations themselves begin to fade. The restless fields that once defined the vacuum may grow quiet, and matter, stable though it is, becomes frozen in eternal stillness. The next stage of this collapse belongs not to galaxies or stars, but to the final structures that gravity once built the planets themselves, especially our own. For even as atoms endure, the materials of Earth have already begun to disperse, following the same relentless law of inertia that now defines the cosmos. Even in the complete stillness of flat space-time, the quantum world continues to hum with its invisible rhythm. Fields fluctuate in silence, particles exchange energy through virtual interactions, and the underlying mathematics of existence continues to function exactly as it always has. Yet in the absence of gravity, this harmony has no scale, no reference, and no consequence beyond its own persistence. The universe has become a stage without curvature, infinite, structureless, and perfectly balanced, upon which the smallest vibrations of reality perform to an audience that no longer exists. At its core, quantum field theory remains unaffected. The electromagnetic field continues to bind electrons to nuclei, and the strong nuclear force continues to confine quarks inside protons and neutrons. These are local interactions, independent of the large-scale geometry of space-time. Gravity's absence does not diminish them, because their power comes from the exchange of gauge bosons, photons, gluons, and weak bosons, whose behavior is defined by local symmetries, not by curvature. Even in a completely flat universe, these fields remain dynamic. Yet there is something haunting in this persistence. In a universe that has lost all structure, the continued existence of atoms and quantum fields feels like a paradox, as though the laws of physics have outlived the stage on which they were meant to act. The electromagnetic field still allows charged particles to interact, but there are no stars, no planets, and no observers left to measure those interactions. Quantum mechanics has become a self-contained whisper, describing fluctuations that no longer affect anything beyond themselves. In this boundless flatness, the vacuum itself becomes uniform. Normally, gravity gives quantum fields a reference point, a curvature, against which energy can be defined. Without it, the zero-point energy of the vacuum has no relative meaning. The concept of potential energy becomes irrelevant because there are no gradients left to compare. Everything that exists does so in perfect equality, an infinite field where all locations and all directions are identical. Even time, within this quantum landscape, loses its asymmetry. In a gravity-filled universe, time and energy are related through curvature. The expansion of the universe defines the arrow of time. Without expansion or contraction, without any change in curvature, time becomes reversible in principle. Quantum events still occur, but they have no preferred direction. The processes of emission and absorption, of creation and annihilation, continue, but their sequence no longer matters. The concept of before and after loses its meaning when the geometry of time itself is flat. Despite this, the individual identities of particles remain intact. The proton retains its mass through its interaction with the Higgs field. The electron still carries its negative charge and orbits its nucleus according to the Schrödinger equation. Light still travels at the same speed through the vacuum because the electromagnetic field defines that speed intrinsically. In the absence of gravity, these relationships remain perfect. The equations that describe them, Maxwell's equations, the Dirac equation, the Yang-Mills field equations, all hold true, though now they operate in infinite isolation. For a brief period, the remnants of the cosmic catastrophe emit faint radiation as neutron stars and black holes dissolve. The energy released floods space-time with high-energy photons, neutrinos, and other particles. But with no gravitational wells to trap or focus them, this radiation spreads uniformly, its density thinning rapidly. Within a few million years, the energy density of the universe becomes nearly uniform. What was once structured into stars, galaxies, and clusters is now an evenly distributed fog of low-energy particles, a thermal equilibrium so perfect that no process can disturb it again. The weak nuclear force, responsible for radioactive decay, continues to operate, but its products are irrelevant. Beta decay, in which a neutron transforms into a proton, electron, and antineutrino, still occurs inside atomic nuclei, but the energy released has nowhere to go. It simply becomes part of the background radiation, blending into the sea of uniform energy. The cosmic microwave background, which once carried the memory of the Big Bang, fades into indistinguishability from all other photons. The universe, once filled with gradients of density and temperature, has become a perfect thermal equilibrium. Over incomprehensible timescales, quantum processes might still create fluctuations in energy density, but without gravity, these fluctuations cannot grow. In the real universe, gravity amplifies tiny irregularities into galaxies and stars through a process called gravitational instability. Without that amplification, fluctuations remain microscopic, rippling quietly across the vacuum and disappearing as quickly as they appear. There will never again be any large-scale structure. For matter, existence becomes eternal but meaningless. Protons and electrons, stable over timescales far longer than the age of the universe, continue to exist indefinitely. Their interactions are limited to the rare collisions that occur by pure chance, perhaps once every trillion years, in any given region of space. When such collisions do occur, they may form temporary atoms or molecules, but these, too, soon separate. There are no forces left to hold them together over distance, no stars to radiate heat, no planets to collect them. This permanence of matter without purpose marks the final consequence of gravity's absence. Gravity is not only the force that binds, but also the one that allows transformation. It drives fusion in stars, compression in planets, and the recycling of elements through supernovae. Without it, the universe is static. There are no processes of renewal, no conversion of energy into form, no evolution. Physics remains, but history ends. In this gravity-free cosmos, every law continues to function, but none of them can create complexity. The strong force still binds nuclei, the electromagnetic force still governs light and charge, and the weak force still mediates decay, but together they can do nothing. Even though galaxies and stars have come apart, the disappearance of gravity does not mean the end of all matter. Gravity is the weakest of the four known fundamental interactions, and the other three, the electromagnetic, the strong, and the weak forces, still endure. These remaining forces continue to operate within atoms and subatomic particles, binding them in ways that gravity never could. While the cosmic structures built by gravity collapse into uniformity, the microscopic world remains intact. The laws of quantum mechanics persist, untouched by the loss of curvature on cosmic scales. At the atomic level, almost nothing changes. Gravity plays no significant role in the stability of atoms or molecules. Its influence there is so small that it can be ignored, even under normal conditions. Electrons remain bound to their nuclei by the electromagnetic force, which is roughly 10 to the power of 39 times stronger than gravity at atomic distances. The protons and neutrons within each nucleus remain locked together by the strong nuclear force, a power that overcomes even the repulsion of their positive charges. Even the weak nuclear force continues its subtle work of transforming one type of particle into another through radioactive decay. In this gravityless universe, therefore, matter itself does not dissolve. A hydrogen atom is still a hydrogen atom. The quantum fields that define the behavior of fundamental particles, electrons, quarks, neutrinos, and photons, continue their dance according to the same rules that have governed them since the birth of the cosmos. Space may be flat, but the underlying quantum fields that fill it still fluctuate. Virtual particles still appear and vanish in fleeting moments, preserving the restless texture of the quantum vacuum. But while atoms persist, the loss of gravity alters the large-scale relationships between them. Normally, gravity sets the stage upon which quantum mechanics plays out, giving physical meaning to space, distance, and curvature. With no curvature, space-time becomes a perfectly flat continuum, and the concept of location loses its absolute meaning. The quantum fields now extend uniformly, with no preferred points or gradients. Matter remains, but it exists in a universe without shape, a sea of particles suspended in featureless flatness. In a strange way, the loss of gravity has purified the laws of physics. The quantum fields operate in their simplest form, uncurved and unperturbed by large-scale structure. Every photon, electron, and proton follows its own path through space-time without deviation. The electromagnetic field continues to propagate at the speed of light, defining interactions between charges. The strong and weak forces continue to operate only within the confines of atomic nuclei. The mathematics of quantum electrodynamics and quantum chromodynamics remain valid, describing perfectly the behavior of the small, even as the large dissolves. Yet gravity's disappearance has profound implications for certain extreme forms of matter. Neutron stars and black holes, which depend entirely on gravitational compression, cease to exist. A neutron star exists because gravity compresses atoms so tightly that electrons and protons combine into neutrons, forming a single atomic nucleus the size of a city. Without gravity, the forces that hold this ultra-dense matter together vanish instantly. The neutrons separate, expanding outward in a burst of energy as the star's matter returns to ordinary atomic density. For black holes, the situation is even more dramatic. A black hole is not truly an object, but a region of space-time where gravity's curvature becomes infinite. It is defined by an event horizon, the boundary beyond which nothing, not even light, can escape. The moment curvature ceases to exist, so too does that boundary. The event horizon dissolves, releasing everything that had been trapped within. The singularity at its center, a point of infinite density, vanishes as well, because density itself has no meaning without curvature to define volume. Whatever particles and radiation once orbited within the horizon now expand freely into flat spacetime, their confinement suddenly erased. These collapses are not explosions in the ordinary sense. They are the release of confinement rather than the transfer of energy. A neutron star does not detonate, it simply expands, its matter returning to ordinary atomic spacing. A black hole does not burst, it ceases to exist, leaving behind a sphere of radiation and high-energy particles dispersing outward. The vast energies associated with these transitions would briefly fill the universe with a flash of radiation, but that light, too, would fade as it expands through the now infinite, uncurved void. The existence of matter without gravity raises deep questions about the nature of space-time itself. In general relativity, matter and energy are inseparable from geometry. They tell space-time how to curve, and curvature tells matter how to move. If curvature is gone but matter remains, then this relationship has been broken. The universe now hosts energy without geometry, motion without direction, and particles without mass in the gravitational sense. Mass, as we understand it, is not merely a measure of substance, it is the source of curvature. In the absence of gravity, the concept of inertial mass still exists, but it is purely a property of resistance to acceleration, not a cause of attraction. Every particle retains its inertial mass, obeying Newton's first law, but its gravitational mass, its ability to curve space-time, has vanished. The equivalence principle, one of Einstein's cornerstones, no longer applies. Matter still moves, but its motion no longer defines geometry. Quantum field theory continues to describe the vacuum with exquisite precision. The Higgs field, which endows particles with mass through interaction, remains unchanged. It gives electrons and quarks their inertial masses just as before. But without gravity, those masses have no large-scale consequence. The Higgs field provides inertia, but no curvature responds to it. Matter, therefore, becomes self-contained, still following the equations of motion, still capable of electromagnetic and nuclear interactions, but isolated forever in the flat expanse of space-time. In this new universe, the atomic and subatomic world remains the only domain where structure survives. Atoms continue to exist in a stable, eternal equilibrium. But without gravity, there is no pressure to bring atoms together into planets or stars, and no cooling to form complex structures. Chemistry still functions, but only locally and fleetingly. Molecules can still form if particles collide by chance, but such collisions become vanishingly rare as matter spreads across infinite flatness. Thus, while gravity's absence does not annihilate matter, it erases the context that gave matter its meaning. The forces that remain are confined to microscopic scales. They bind particles into atoms, but they cannot bind atoms into worlds. The cosmos has become a mosaic of isolated quantum islands, drifting through infinite, uncurved emptiness. And yet, even here, at the smallest scales, the end of gravity is not only a cosmic catastrophe, it is the quiet, complete unraveling of our own world. Earth, once bound by the invisible hand of curvature, now drifts apart atom by atom. For 4.5 billion years, gravity shaped every layer of the planet, from the molten iron at its core to the thin veil of air that surrounded its surface. Without that binding force, all of it begins to come undone. At the moment gravity vanishes, the planet does not explode in fire or light. There is no blast, no shockwave, only the instantaneous absence of weight. Every atom that once felt a downward pull now moves according to inertia alone. The crust, the mantle, and the core no longer have any reason to remain connected. Their cohesion, once defined by gravitational compression, dissolves at every scale. The first signs of collapse, or rather, dispersal, occur within seconds. Earth's atmosphere begins to rise, not because it is heated or pushed outward, but because there is no longer any force to keep it near the surface. Molecules of nitrogen, oxygen, and carbon dioxide, freed from the planet's pull, drift upward in all directions. The blue of the sky fades into black as air thins, expanding rapidly into the void. Within moments, the pressure at sea level falls to near zero. The familiar concept of breathable air ceases to exist. The oceans respond next. Water, which once pressed down on itself under the weight of thousands of meters, begins to lift and disperse. The surface rises into colossal plumes of vapor that stretch upward and outward, following straight trajectories into space. The boiling point of water drops instantly as atmospheric pressure disappears, so the oceans flash into steam. In a few seconds, the great basins of the world become churning clouds of vapor. Within minutes, those clouds unravel into a mist of molecules spreading evenly into the emptiness. The Pacific, the Atlantic, and every river and lake vanish into an expanding haze of hydrogen and oxygen drifting among the stars. The solid body of the planet follows. The crust, which had rested upon the slow currents of the molten mantle, fractures into fragments as internal pressure escapes. Beneath it, the mantle, no longer compressed, expands violently. The iron core, once held under pressures exceeding 3 million atmospheres, releases its energy in a silent, unstoppable surge. The planet's rotation tears it apart, as the centrifugal force of its spin now acts unchecked by gravity. Fragments of rock, metal, and molten silicate are flung outward along tangential paths, each one following a perfect straight line determined by the motion it had at that instant. In the span of minutes, Earth transforms from a sphere into an expanding swarm of debris. Mountains, continents, and oceans no longer have meaning. All that remains are scattered fragments of their atoms, traveling away from one another at escape velocities that no longer need to be achieved, because escape itself is now effortless. From space, the sight would be surreal if there were anyone left to see it. The blue sphere that once shone under sunlight has become a cloud of glowing dust, expanding at thousands of kilometers per hour. The atmosphere's remnants shimmer briefly as they reflect the last light of the sun, before that light, too, fades. As the fragments drift farther apart, collisions become rare, then non-existent. Within hours, Earth's mass is so diffuse that it could pass through the orbit of the Moon without leaving a trace of its former existence. In the absence of gravity, even the heat stored within Earth dissipates differently. Normally, heat moves by conduction and convection, driven by density differences and pressure gradients. But those gradients no longer exist. The energy that once powered volcanoes and tectonic motion is now spread evenly among the fragments, cooling as it expands into the vacuum. There is no eruption, no explosion, only expansion and silence. The materials that once formed Earth separate according to their own inertia. The dense metals of the core travel outward at different speeds than the lighter silicates of the crust. The result is a vast, diffuse sphere of matter spreading in all directions. Over time, that sphere becomes so large that it merges with the general debris of the solar system. The distinction between planet and space fades. The biosphere, the thin film of life that once covered Earth, vanishes instantly. Gravity was essential to every process that sustained it. It kept the atmosphere thick enough for breathing, the oceans deep enough for circulation, and the blood in every organism flowing in balance. When gravity disappeared, every biological system collapsed within seconds. Air and water escaped from lungs and cells alike. Without pressure, blood boiled. Without weight, orientation was lost. Even the molecular structures that defined life, proteins, membranes, and DNA, drift apart as their environment disintegrates. Life ends not in flame, but in the instant loss of order. In this brief moment of dissolution, the memory of Earth, its shape, its colors, its seasons vanishes into the featureless geometry of spacetime. The planet that had once been home to oceans, forests, and cities is now a cloud of atoms, indistinguishable from the dust that once filled the void between worlds. And yet, even as the planet falls apart, the physical laws that govern its components remain intact. The electromagnetic forces that hold atoms together persist. The chemical bonds within molecules still obey quantum rules. But these bonds can no longer form large-scale structures because the atoms themselves are too far apart to interact. The Earth that was once a living system of self-sustaining cycles has become a faint whisper of its former matter, spread thin across infinite space. In the hours that follow, the last visible traces of the planet fade completely. The dust and vapor cool as they expand, losing the faint glow of thermal radiation. The molecules that once made up oceans and rocks now drift as isolated specks of matter, moving endlessly through a universe that no longer curves around them. There are no boundaries left, no return paths, no orbit in which to gather again. The disintegration of Earth marks the final dissolution of planetary form. The same process unfolds on every other world. Venus and Mars scatter into clouds of rock and gas. Jupiter and Saturn disperse their hydrogen and helium into the vacuum, forming immense but fading spheres of vapor. The smaller bodies, moons, asteroids, and comets follow their own inertial paths, spreading throughout space. The solar system as a concept has ceased to exist, replaced by a diffuse halo of atoms moving without destination. If a single observer could somehow survive and watch from a distance, they would see the place that was once a cradle of life dissolve into a veil of dust, and then into nothing at all. But there is no observer and no light to carry the image. The planet has returned to the same state it began, from a cloud of atoms in an expanding void. Only now there is no gravity to begin the cycle again. The story of Earth's physical disintegration is the story of all worlds. Gravity once gathered chaos into order, transforming gas and dust into spheres of matter capable of holding oceans, atmospheres, and life. Without it, those same forces unwind, returning the universe to the simplicity it had before structure existed. The fragments of Earth continue to drift outward, carried by their inertia into an ever-expanding emptiness. They will never slow, never return, and never meet again. Their motion is eternal, their meaning erased. And so ends the history of a planet that once knew the pull of the sun, the tides of the moon, and the weight of its own gravity. In the stillness that follows, all that remains is motion, the last echo of a world unbound. In the hours and days following gravity's disappearance, the physical remains of Earth continue their silent dispersal. Every fragment, from grains of sand to mountains, moves away from every other piece in perfect linear motion. The process is governed entirely by inertia. There are no collisions to slow it, no atmosphere to shape it, and no curvature to contain it. The planet's final act is not an explosion, but a quiet unraveling, a vast diffusion of mass across what was once its orbit. The disintegration follows clear physical laws. Each portion of matter retains the velocity it had when gravity vanished. Near the equator, where Earth's rotation once produced the greatest tangential speed, nearly 1,670 kilometers per hour, fragments move fastest, forming a subtle bulge in the expanding debris cloud. Material near the poles drifts more slowly, leaving behind an elongated shape that gradually evens out as distances grow. The result is an expanding sphere of matter centered roughly where Earth's core once resided, though the term center now has no physical meaning. Thermodynamics defines the next stage of this transformation. The heat once confined within Earth's mantle and core now escapes freely into space. Under normal conditions, such heat would move through conduction, convection, and radiation, but without pressure and containment, conduction and convection vanish. Radiation remains the only path for energy to escape, and as the fragments spread, they cool rapidly. In the first few hours, molten materials solidify into irregular clumps of rock and metal. Within days, their temperature drops toward that of the surrounding vacuum, only a few degrees above absolute zero. This cooling process marks the end of all geological activity. Volcanism, tectonic motion, and magnetic field generation all depended on gravitational compression and the circulation it drove within Earth's interior. Without it, convection ceases. The liquid iron that once created Earth's magnetic field solidifies into static fragments. The magnetosphere, already gone with the planet's structure, leaves behind no trace of its former strength. Even the magnetic signatures trapped in the rocks lose meaning, for there is no longer an organized planet to contain them. As the fragments expand outward, their density decreases exponentially. After a single day, the debris cloud stretches across millions of kilometers. After a week, it fills the region that was once the orbit of the Moon. Within a month, it has thinned to the point where individual pieces are separated by distances greater than the size of the planet itself. Eventually, the fragments are spaced so far apart that they no longer interact at all. The total energy of this dispersal remains conserved. Before gravity vanished, the planet's energy was divided among rotational, thermal, and gravitational components. With the removal of gravitational binding energy, that stored potential becomes kinetic energy. The result is not a sudden release, but a redistribution. The energy that once held matter together now carries it outward. The Earth's mass continues to move at the same total energy, but now that energy is purely inertial, with no possibility of reconversion into structure. From a mechanical perspective, this transition is final. Without gravity, there is no restoring force that could ever bring the fragments together. In the real universe, even catastrophic impacts or supernovae leave behind debris that eventually gathers again under mutual attraction. Here, that second act is impossible. Every trajectory is infinite, every separation permanent. The speed of dispersion varies with position. The outer layers of the planet, crust, oceans, and atmosphere, were less tightly bound and move away more rapidly. The dense materials of the core move more slowly, but inevitably follow. In a few decades, the expanding sphere of debris becomes indistinguishable from the diffuse gas and dust that fill interstellar space. The fragments lose their identity as remnants of a planet and merge into the uniform background of atomic matter. At the molecular level, the composition of these fragments remains mostly unchanged. Silicates, metals, and ices persist as they cool, their chemical bonds intact. Radiation from the dying sun and the surrounding environment gradually strips electrons from some atoms, ionizing portions of the debris cloud. Over centuries, cosmic radiation and particle interactions may erode larger fragments into smaller dust grains. But without gravity, even this erosion produces no meaningful change in structure. There is no accumulation, no erosion cycle, no weathering. The atoms simply drift farther apart. Eventually, the matter that once formed Earth reaches interstellar distances. Each fragment continues along its path indefinitely, becoming part of a faint stream of particles stretching across light years. Within 1 million years, this material disperses completely into the surrounding void. The density becomes so low that, within the space once occupied by the solar system, only a handful of atoms would exist per cubic meter, less than the density of the interstellar medium itself. detection of Earth's remnants would become impossible. Even the most sensitive instruments, were any to exist, could not distinguish its atoms from the general background of space. The planet's signature in gravitational and electromagnetic fields disappears entirely. Earth no longer influences anything, not because its mass is gone, but because its distribution is perfectly uniform. This diffusion marks the thermodynamic death of a planet. The second law of thermodynamics dictates that isolated systems move towards states of maximum entropy. And without gravity, there is no mechanism to reverse that process. The Earth, once a site of constant disequilibrium of flowing heat, cycling water, and evolving life, has reached perfect uniformity. Entropy has reached its limit. No further increase is possible. In the absence of pressure and compression, even the remnants of the atmosphere achieve equilibrium with the vacuum. The molecules expand until their separation becomes so great that they no longer collide. Each molecule, perhaps once part of a breath or a cloud, now travels alone. Its velocity remains constant, its path infinite, and its existence irrelevant to any other. To visualize this final condition is to imagine a sphere of space once vibrant with weather, color, and sound, now filled with particles spaced light seconds apart. The familiar boundaries between solid, liquid, and gas have lost their meaning. The planet's matter has been diluted to invisibility. There is no horizon, no surface, no edge. And yet, in this perfect stillness, one truth remains. The laws that govern motion, energy, and thermodynamics have not changed. They continue to apply, even in emptiness. The energy that once shaped mountains and powered volcanoes has not vanished. It has simply become uniform. The universe, stripped of curvature, has reached a state of pure equilibrium. What was once the Earth now drifts as a diffuse cloud of atoms, moving eternally through flat spacetime. Its fragments, cooled to near absolute zero, carry the chemical memory of a world that once existed. But that memory is silent, for there is no gravity to gather it, no light to warm it, and no observer left to remember what it was. The disintegration of Earth is only one chapter in a larger process. Every planet, moon, and asteroid has followed the same path. The solar system, once a balanced dance of mass and motion, is now a ghostly haze of scattered matter, but the effects do not end here. As the remnants of worlds fade into interstellar space, the same process unfolds on scales beyond imagination across galaxies, clusters, and the cosmic web itself. And so, from the loss of a single planet to the dissolution of all structure, the universe continues to flatten. The next step is the breakdown of every galactic bond, until even the largest structures ever formed by gravity dissolve into featureless infinity. In the months and years that follow, the expanding fragments of Earth grow colder, darker, and more distant from one another. The last vestiges of heat that once flowed through the mantle radiate into the emptiness, their energy diffusing outward as infrared light. That radiation travels forever through a universe where it will never again be absorbed or reflected. There is nothing left to stop it, nothing to warm, nothing to illuminate. Every material that once made up Earth now exists as a separate traveler through space. The iron from the core drifts as grains of solid metal, cooling until their temperature matches that of the surrounding vacuum, a few degrees above absolute zero. Silicates from the crust and mantle freeze into tiny glassy shards, their molecules locked in place. Even water, once the most dynamic and life-giving substance on the planet, has become an invisible vapor stretched across distances so immense that no two molecules will meet again. This process continues without end, governed by the same physical laws that once built the planet. The conservation of momentum ensures that each fragment moves at constant speed. The conservation of energy ensures that every bit of heat and radiation finds its way into the infinite void. Thermodynamics guarantees that no new structure will ever emerge, because there are no gradients left to exploit. In the absence of gravity, these laws complete their work perfectly. Everything that could spread has spread. Everything that could cool has cooled. The chemical identity of Earth survives in a technical sense. The atoms of carbon, oxygen, iron, and silicon remain exactly as they were, their nuclei stable, their electrons bound in familiar configurations. But these atoms are now scattered across such distances that the concept of chemistry itself has become meaningless. There are no collisions, no reactions, no molecules forming or breaking apart. Each atom moves alone, obeying the quantum mechanical rules of existence, but cut off from all others by separation so vast it might as well be infinite. Over longer spans of time, the cloud of matter that was once Earth becomes indistinguishable from the general background of interstellar material. Its density approaches that of the rarefied hydrogen that fills space only a few atoms per cubic meter. Within 1 million years, the region once occupied by the solar system contains no detectable trace of the planet that gave rise to life. The debris of Earth has merged seamlessly into the fabric of the universe, a uniform field of atoms, drifting without direction. Even the light that once marked its disintegration fades. The faint thermal glow of the cooling fragments stretches into longer and longer wavelengths, eventually merging with the background radiation that fills all of space. The information that once described Earth's surface, its mountains and seas, its weather and its living beings, has been dispersed as entropy, not destroyed, but rendered unrecoverable. The second law of thermodynamics has completed its work, spreading all distinctions into equilibrium. If one were to trace the individual atoms of Earth, their journeys would continue forever. The carbon that once formed the backbone of living cells now drifts as a free atom, perhaps moving a few meters every second through the boundless void. The iron that once pulsed in blood travels at thousands of kilometers per hour, but it has nowhere to go. The silicon that once shaped continents and sand dunes spins slowly, alone, its chemical bonds unbroken, yet meaningless. Each fragment, each particle, carries the memory of a world, but there is no longer any system to interpret that memory. In this final stage, the transformation of Earth has reached absolute physical completion. The planet has not simply been destroyed, it has been erased from the architecture of the cosmos. Its materials persist, but its form, its gravity, and its motion as a coherent object are gone. There are no longer boundaries between Earth and space, because space itself no longer curves to distinguish one place from another. Every direction is the same, every distance infinite, every motion eternal. The disappearance of Earth also signifies the death of locality, the concept that one region of the universe can differ from another. In a gravity-free cosmos, there are no wells of potential energy, no places where matter might collect. Every point in spacetime is equivalent. The universe has become a perfect continuum of uniform density and temperature. Matter exists, but structure does not. And yet, this absolute stillness is not the same as nothingness. The fundamental fields still permeate space. The electromagnetic field, the Higgs field, and the quantum vacuum itself continue to exist. They form the underlying texture of reality, invisible, constant, and unchanging. But these fields are now static. They fluctuate in tiny random ways. Yet those fluctuations never grow into anything larger, because there is no gravity to amplify them. The universe has entered a state that physicists would describe as thermodynamic death, the final equilibrium in which all processes have ceased. If consciousness had somehow survived to witness this, it would experience nothing but uniformity. There would be no sense of direction, no passing of days, no visible change. Every second would be indistinguishable from every other. In such a world, even the idea of observation becomes meaningless. For observation requires contrast, and contrast has ceased to exist. The matter that once composed Earth will travel forever, unperturbed and unchanged, through an uncurved spacetime. Each atom, each photon, continues along its inertial path, obeying the simplest possible rule of motion, to move in a straight line at constant speed. That rule, the most basic expression of Newton's first law, now defines the entire universe. There are no forces left to modify it. And so, Earth's disintegration is complete not merely as a physical event, but as a transformation of meaning. The planet that once nurtured life and thought has been reduced to an eternal stillness of form. Its atoms remain, its energy remains, but the complexity that once defined it is gone. Gravity's absence has erased not only the structure of matter, but also the possibility of narrative, of cause and effect, of future and past. This is the end of planetary history, but not yet the end of the story. The same fate that has overtaken Earth extends outward across the galaxy and beyond, dissolving every world, every star, and every cluster. The Milky Way, once a swirl of motion and light, continues to lose coherence until even its faint traces vanish. What began with the disappearance of a single force has become the erasure of cosmic structure itself. In the next stage, we leave behind the ruins of planets and descend into the deeper unraveling of time and spacetime, a universe that not only loses its form, but the very curvature that once defined the difference between existence and nothingness. The moment gravity vanishes, life loses its foundation. Every heartbeat, every breath, every step ever taken has depended on the steady pull of that invisible field. It is gravity that gives shape to bodies, that holds air close to the surface of a planet, that pulls water down mountains and blood through veins. Without it, there is no up or down, no pressure, no orientation, and no equilibrium. Life, so delicately adapted to the curvature of space-time, cannot survive in its absence for even a second. When gravity disappears, the atmosphere itself becomes the first casualty. Air molecules, once held to the planet by the pull of mass, drift outward in all directions. Within seconds, the pressure that allows lungs to function drops to zero. The nitrogen and oxygen that once formed the sky expand into space, forming a thinning halo that vanishes as quickly as it forms. The concept of air of breathing ends. There is no time to gasp. The very medium of sound, of voice and motion has gone. Silence replaces everything. Inside the human body, catastrophe follows at the molecular level. Every process that keeps a person alive is calibrated to one atmosphere of pressure, to the constant weight of air pressing upon skin and lungs. When that pressure disappears, gases expand uncontrollably. The lungs collapse inward as air rushes out. Capillaries burst as dissolved gases escape from blood. Within seconds, consciousness fades. Within a minute, the body is unmade from within, tissues ruptured by the expansion of fluids and the evaporation of moisture. The eyes boil first, then the mouth and throat, as water vapor escapes into vacuum. There is no pain, the nerves fail too quickly for that. Only the instant loss of balance, of sensation, of self. The body freezes in seconds, the remaining heat radiating away into the cold of space. This is not a violent death, it is dissolution, an unbinding of the structure that gravity once kept in place. But the disintegration of the individual is only the smallest echo of a larger collapse. With gravity gone, the planet itself is unraveling beneath. Oceans rise into steam, rock fractures, air thins into nothing. Every building, mountain, and molecule moves according to inertia alone. The ground no longer presses upward. The sense of standing disappears. There is no longer a surface or a sky, only fragments of what once was, drifting outward in straight lines. In orbit, the same fate reaches everything built by human hands. Satellites, stations, and spacecraft had depended on their balance between inertia and gravity, continuous free fall around Earth. Without gravity, their orbits cease to curve. Each one flies away along a tangent, carrying with it the last traces of human technology. Communication ends in an instant. The network of satellites that once surrounded Earth, silent sentinels of a civilization, vanishes into the dark. Even if a human could somehow survive those first moments, the loss of gravity would destroy every physiological process that defines life. The human body evolved under one constant acceleration, the steady pull of 1G. Bones, muscles, and organs depend on it to maintain structure. In its absence, blood no longer settles toward the feet, but pools evenly. Astronauts in orbit experience a small version of this. Their faces swell, their eyes strain, and their bones begin to dissolve. But in true zero gravity, where even the curvature of spacetime has gone, these changes occur instantly and irreversibly. The heart, evolved to push blood upward against the pull of gravity, overcompensates in its absence. Blood rushes to the head, raising internal pressure beyond survival. The vestibular system in the inner ear, responsible for balance, sends conflicting signals to the brain. Orientation ceases to exist. The sense of up or down, already meaningless, becomes a memory that fades with consciousness. Life on a planetary scale fails with the same precision. Gravity guided every tree root downward, every stem upward. It directed the flow of rivers, the circulation of air, and the stratification of oceans. When it disappears, those cycles stop instantly. Water evaporates into space. Nutrients no longer circulate. The microscopic organisms that drive ecosystems die as their fluids expand, their membranes rupture, and their chemistry stops. Within seconds, the biosphere, the thin film of life around the planet, becomes a drifting cloud of organic fragments. For a brief moment, the Earth's former surface is filled with a strange stillness. Leaves and soil rise into the air as though in slow motion, then drift away forever. Waves rise, but never fall. Mountains crumble into dust, and dust disperses without direction. It is as though the concept of weight itself has been erased from reality. Biological death, in this gravityless world, is not an event, but a transformation. The atoms that once composed cells continue to exist, but they no longer belong to living systems. Proteins, lipids, and DNA separate into simple molecules, then into isolated atoms, each moving on a straight path away from the others. Life does not end in destruction, but in diffusion, an expansion into uniformity. If gravity had remained even for a few seconds longer, the destruction might have been spectacular. Planets tearing apart, stars collapsing, galaxies unraveling. But the truth is quieter and more final. Without gravity, there is no collapse, because collapse requires curvature. Everything simply moves away. The end of life, like the end of the cosmos, is silent. And yet, within that silence lies an extraordinary truth. Life existed only because gravity made order from chaos. It gathered matter into worlds stable enough for chemistry to begin, and held energy in balance long enough for evolution to occur. Gravity shaped not only the physical universe, but the biological one. Every cycle of growth, every heartbeat, every orbit of a planet was a translation of curvature into motion. When it disappears, the equations still hold, but the meaning behind them does not. The strong and weak nuclear forces continue to bind particles. Electromagnetism still governs charge and light. But without gravity, there is no large-scale order, no stars, no planets, no surfaces where chemistry can organize into biology. The physical framework remains, but the context for life is gone. The human story, brief against the scale of the cosmos, ends not in fire, but in the return to equilibrium. The atoms that once formed living bodies rejoin the dust of the planet, then drift into interplanetary space, then into the quiet background of the galaxy. Over millions of years, they spread until they are indistinguishable from the interstellar medium. The matter that once thought, dreamed, and loved becomes evenly mixed with the rest of existence. This is not tragedy, but completion. For life was gravity's most intricate pattern, a momentary organization of energy and matter sustained by curvature. When that curvature vanishes, the pattern dissolves, and the universe returns to balance. The disappearance of gravity is not merely the death of life. It is the restoration of symmetry. In that symmetry, there are no beginnings or endings. There is only motion without direction, existence without structure. The pulse of life was gravity's rhythm, and now that rhythm has stopped. What remains is silence, the equilibrium that was always waiting at the end of time. The species that once studied gravity has become its final lesson. Life was never separate from the force that shaped it. It was gravity itself, exploring its own consequences. The last breath, the last heartbeat, the last orbit, all were echoes of the same curvature. When that curvature flattened, the echo faded. The story of biology ends as it began in stillness. Gravity's disappearance erases life, but not the laws that made it possible. The equations remain, perfect and complete, describing a universe that no longer needs to move. Life, like light, has traveled as far as it can. In the quiet that follows, existence returns to its simplest form: motion without meaning, energy without contrast, perfection without witness. The universe has forgotten what it was like to be alive. The disappearance of gravity is not just the loss of a force, it is the undoing of the structure of time itself. Gravity is not an external pull acting across space, it is the shape of space and time, the bending of existence around energy and mass. When that bending vanishes, the geometry of reality flattens, and with it, the rhythm of time dissolves. What remains is not destruction, but stillness, a universe of motion without change, of energy without sequence, of existence without history. Einstein's greatest revelation was that gravity and time are inseparable. Mass curves space-time, and that curvature dictates how time flows. Near a massive object, time slows. Far from it, time accelerates. This is not illusion, it is the geometry of reality itself. Every clock, from the ticking of an atom to the orbit of a planet, runs at a pace determined by its place in this curvature. When gravity disappears, this variation ends. Every point in the universe ticks at the same rate, perfectly synchronized, perfectly uniform. The flattening of space-time is the flattening of time. There are no longer wells of slower duration or peaks of faster flow. A second becomes identical everywhere, and in that sameness, meaning evaporates. Time exists mathematically but not physically, because physical time depends on contrast, on the difference between faster and slower, on the tension between curvature and motion. Without curvature, there is no tension, and time becomes an unbroken continuum, without rhythm or direction. Imagine the universe as a great ocean of space-time, rippling and curving wherever mass exists. Planets, stars, and galaxies are the stones that weigh upon that ocean, bending its surface into valleys and peaks. Light follows those curves. Motion finds its path within them, and time flows differently at each depth. But now the ocean has stilled. Every ripple, every wave, every depth is gone. The surface is flat, calm, infinite. Motion continues, but it has lost its meaning. For light, the consequences are absolute. In a curved universe, light follows the shape of space-time, bending around stars, tracing arcs through gravitational fields, stretching its wavelength as it climbs out of wells of curvature. Without gravity, there are no wells, no stretching, no bending. Light moves in perfect straight lines forever. It does not redshift because there is no expansion, no gravitational potential, no change in space-time itself. Every photon travels unchanged, unaging, unmeasured because measurement requires difference, and difference no longer exists. To the human mind, which experiences time through motion and change, such uniformity would feel like eternity. Without gravitational curvature, there are no longer faster or slower processes. A particle moving across 1,000,000 kilometers experiences the same flow of time as one at rest. There is no longer any sense of before or after, because the sequence of events is unaltered by geometry. Every moment becomes identical to every other. Time continues, but the universe no longer participates in it. In a way, this is the final form of relativity. Special relativity describes flat space-time, the geometry without gravity, where time and space are unified in a constant relationship. General relativity extends that idea to curved space-time, where energy and mass distort geometry. When gravity disappears, the universe reverts to the simpler case not because the laws have failed, but because they have fulfilled themselves. The curvature term in Einstein's field equations falls to zero. Space-time becomes Minkowski space, a four-dimensional grid of perfect uniformity. The universe is not empty, it is complete. This completeness is not peace in a human sense. It is absolute equilibrium, a state in which nothing can happen, because every possible configuration already exists simultaneously. Entropy has reached its maximum value. There are no gradients left to drive change. Energy is evenly distributed, matter evenly dispersed. The universe has reached its thermodynamic and geometric end, a cosmos, without curvature, without acceleration, and without future. And yet, the laws of physics remain untouched. They do not vanish when gravity does. They simply become static. Newton's first law, the law of inertia, now defines everything. Every particle moves in a straight line at constant speed. Every trajectory is infinite. There are no collisions, no orbits, no centers of attraction. The same rule that governs a drifting atom now governs the entire universe. If one could observe this reality, though observation itself would have no meaning, the universe would appear motionless. Every particle moves, but without a frame of reference. Motion is indistinguishable from rest. Light crosses infinite distances, but since no event alters its path, there is nothing to measure its passage. Time seems frozen not because it has stopped, but because it has nothing left to measure. In this geometry, cause and effect lose their significance. In curved space-time, light cones tilt and twist, defining what events can influence others. Curvature gives direction to causality. But in flat space-time, light cones are identical everywhere. Perfect, parallel, unchanging. The universe has become causally uniform. Every event follows the same rule, and nothing distinguishes one region of space-time from another. Without curvature, there is no narrative, only existence. This condition might sound like nothingness, but it is not. Energy still fills the universe. Fields still vibrate with quantum fluctuations. The fabric of reality still hums with zero-point energy, the faint whisper of quantum motion that never ceases. But these fluctuations no longer accumulate into structure, because gravity is what once amplified them. In this final stillness, even the uncertainty of quantum mechanics becomes harmless. Its effects spread evenly across the infinite flatness. The absence of curvature means the end of relativity as experience, but not as truth. The relationship between time and space still exists. It has simply lost context. Without gravity, there are no observers, no clocks, no masses to define reference frames. Relativity remains perfect, but sterile, an equation without variables, a song without sound. To imagine this reality is to confront the limits of perception. Every sense we have, every concept of change or sequence, depends on curvature. The slowing of a clock, the fall of an apple, the orbit of a planet, all are expressions of space-time bending around energy. Remove that bending, and everything becomes uniform. In that uniformity, perception itself cannot exist. And yet, this perfect flatness carries a kind of completion. The equations of the universe, from Newton to Einstein, describe a trajectory from complexity to simplicity. Gravity created asymmetry, and asymmetry created time. Time allowed motion, motion allowed change, and change gave rise to awareness. Now that curvature is gone, the cycle has closed. The universe has returned to the state it left at its birth: unbroken symmetry, absolute balance. There is an irony in this ending. The same principle that gave birth to time has now erased it. Gravity, by creating curvature, created the possibility of sequence of one event following another, of history, of evolution. Its disappearance restores timelessness. The clock that once measured ages now measures nothing, because all moments are identical. The universe, stripped of curvature, has achieved perfection, and perfection, in physics, is indistinguishable from stillness. In this final equilibrium, the distinction between geometry and existence disappears. Space-time has flattened completely, but the memory of curvature remains embedded in its laws. The equations still hold the potential for bending, even though there is nothing left to bend them. The universe is a map without terrain, a law without motion, a structure without story. The flattening of space-time is not an end, but a revelation. It shows that gravity and time were never separate phenomena. They were two expressions of the same truth, that curvature gives reality its direction. To exist in time is to exist in gravity's field. Without curvature, there is no change. Without change, there is no time. And so, the disappearance of gravity marks the quiet conclusion of relativity itself. The universe remains, but it no longer evolves. The stage persists, but the play has ended. Every actor, every atom, every photon, every particle continues its motion across the infinite flatness, unaware that the story has already concluded. Time has not stopped. It has become meaningless. The disappearance of gravity reshapes not just worlds or systems, but the very structure of the cosmos. The scale of existence that once stretched across billions of light years becomes a static geometry, a universe stripped of hierarchy and purpose. Galaxies, stars, and planets were never isolated entities. They were patterns carved by curvature, temporary concentrations of matter in a field defined by attraction. Without gravity, those patterns dissolve. The universe remains vast, but its vastness is meaningless, because nothing within it connects to anything else. In the real universe, gravity gives rise to structure on every scale. It holds stars together through hydrostatic balance, binds galaxies through dark matter halos, and organizes clusters into filaments that weave the cosmic web. It is the silent engineer behind every visible pattern in the sky. When that engineer vanishes, the blueprint itself fades. The solar system would be among the first casualties. Without the sun's gravitational pull, Earth and the other planets would drift away along straight trajectories, continuing forever in the directions they were moving at the moment of gravity's disappearance. The sun, too, would unravel not in a fiery explosion, but in a sudden and absolute cessation. Its nuclear fusion depended on gravity's inward pressure, which balanced the outward force of radiation. Without that inward pressure, the fusion reaction stops instantly. The core cools, the light fades, and the star that once gave life becomes inert gas, dispersing into space. On larger scales, galaxies meet the same fate. Every star in the Milky Way follows an orbit defined by the gravitational field of its neighbors and the unseen mass of dark matter. Without that field, those orbits cease to curve. The stars shoot away along straight paths, drifting apart at hundreds of kilometers per second. Over millions of years, the once beautiful spiral dissolves into an expanding cloud of isolated suns. Over billions more, even those suns extinguish. The Milky Way's light fades until it becomes indistinguishable from the cosmic background. Clusters of galaxies, bound together by the same force, disintegrate as well. The large-scale structure of the universe, the filaments and voids that stretch across hundreds of millions of light years, dissolves into uniformity. What remains is a smooth, featureless distribution of matter and radiation. The universe loses its architecture, returning to the evenness it once had before gravity sculpted it. Dark matter, which interacts with the rest of the cosmos only through gravity, becomes irrelevant. Its invisible scaffolding, which once shaped galaxies and clusters, vanishes in an instant. Its particles continue moving through the universe, but without interaction or influence. The cosmic web collapses not inward, but outward, expanding into infinity until density becomes uniform everywhere. Dark energy, too, loses meaning. In the real universe, dark energy appears as a property of spacetime itself, causing the acceleration of cosmic expansion. But without gravity, there is no curvature for it to act upon. Expansion halts. The metric of spacetime becomes static, frozen at the moment. Curvature vanished. The cosmos no longer stretches or contracts. It simply exists, in perfect stillness. At this scale, energy remains, but energy has lost its gradients. Temperature, pressure, and density, the quantities that once varied across regions, become the same everywhere. Entropy reaches its maximum value, not through disorder, but through uniformity. The universe has achieved thermal equilibrium. Every photon, every atom, every particle now carries the same energy distribution. This state, predicted by the laws of thermodynamics, is the ultimate fate of any isolated system: heat, death. But without gravity, it is a heat death reached instantly. The long, slow drift toward equilibrium, which in the real universe would take unimaginable eons, occurs in no time at all. There are no barriers to mixing, no wells to trap energy, no asymmetries to sustain gradients. Every distinction vanishes. From a cosmological perspective, this flat, featureless state is the simplest possible solution to Einstein's field equations. When curvature is zero, spacetime becomes Minkowski space, the same geometry described by special relativity. It is infinite, uniform, and eternal. There is no expansion, no contraction, no birth or death. The cosmos is a static equation without change. To an external observer, a concept that no longer has meaning, the universe would appear as a faint, unchanging glow, its matter and radiation evenly distributed. But even this description is incomplete, because observation requires time, and time itself has lost contrast. There is no way to distinguish one moment from another when nothing evolves. For billions of years before this flattening, the universe had been a dynamic interplay between gravity and expansion. Galaxies collided, stars lived and died, black holes grew and evaporated. Those processes gave the cosmos texture, a story written in light and motion. Now, that story has ended. The disappearance of gravity is the final chapter in cosmological history, the point at which all motion becomes meaningless, because every point in space is the same as every other. It is tempting to call this an ending, but physics describes it more accurately as completion. The universe has achieved its simplest configuration. All potential energy has been exhausted. All curvature has been smoothed away. The cosmos has reached its ground state, the lowest possible energy level. It no longer changes because change itself requires imbalance, and imbalance has been erased. Quantum fields still hum beneath this stillness, filled with zero-point energy, the faint whisper of existence that cannot vanish, even at absolute equilibrium. But these fluctuations do not build structure. They are random and self-canceling. They flicker everywhere, producing nothing. The universe persists not as a place, but as a condition, a self-consistent geometry in which nothing happens, because everything that could happen has already become part of the balance. If one could describe this state poetically, it would be a universe at rest, a vast ocean of space-time, perfectly calm. There are no ripples left to disturb its surface. Every wave has flattened, every tide has ended. The motion that once defined creation has given way to stillness so complete that it no longer requires definition. And yet, within this calm lies the memory of what was. The structure of the laws remains, even though their expression has ceased. The equations of general relativity, quantum mechanics, and thermodynamics all remain true, but they have reached their simplest solutions. The cosmos has not broken its laws, it has fulfilled them. Gravity's disappearance is not a failure of physics, but its perfection. This, then, is the fate of the universe without gravity. Not fire, not collapse, but symmetry. The same curvature that once built galaxies and worlds has been undone, leaving behind a geometry so flawless that it cannot evolve further. Time, space, energy, and matter continue to exist, but they no longer interact in any meaningful way. The cosmos has returned to silence. Its complexity, its turbulence, its light, all have dissolved into balance. What remains is the purest form of existence, the equation without narrative. From this point onward, there can be no future. There is no motion left to measure, no change to record. The universe has reached the only state from which no transformation is possible. It has become eternal. In the vast stillness that follows the disappearance of gravity, the universe at last becomes silent. Every orbit, every vibration, every structure once shaped by curvature has dissolved. The galaxies have drifted apart, the stars have gone dark, and time itself has lost its rhythm. The cosmos, which began as a restless sea of energy, has reached perfect symmetry, a state so balanced that nothing more can occur. It is here, in this quiet perfection, that the meaning of gravity reveals itself. Gravity was never simply a force. It was the architecture of motion, the invisible framework that turned geometry into story. It was the curvature of existence itself, the way mass and energy shape the flow of time and space. Without it, there is no direction, no process, no becoming. The universe without gravity is not dead, but complete. Everything that could ever happen has already done so. What remains is equilibrium, infinite, motionless, absolute. To understand gravity is to understand why the universe has form at all. The other forces, the electromagnetic, the weak, and the strong, act within atoms and stars, but only gravity connects everything. It is weak, almost absurdly so, but infinite in reach. It is the reason that matter coalesces, the reason that energy finds pattern, the reason that time moves unevenly. Its weakness is not a flaw but a gift. Because it acts so gently, it allows the cosmos to unfold slowly, permitting billions of years for stars to shine and life to arise. Had gravity been stronger, the universe would have collapsed upon itself long before complexity could form. Had it been weaker, matter would never have gathered into stars. Its delicate balance is the quiet miracle of existence, a fine-tuned symmetry between order and chaos, between collapse and expansion. The universe's endurance, and every life within it, depended on that balance. Through its presence, gravity gave rise to the conditions for meaning. It bent space-time so that motion could exist. It sculpted matter into stars, and it stretched time so that change could be felt. Every process that gave rise to life, the fusion of hydrogen in stars, the birth of elements, the formation of planets, was gravity's work. It is no exaggeration to say that the universe became conscious through its curvature, for it was only in the slow unfolding of gravity's rhythm that awareness could evolve, question, and understand. Even now, in imagination, we exist because of it. The very act of wondering what the universe would be like without gravity is an expression of gravity's influence for our bodies. Our thoughts and our time are products of its pull. The neurons that fire in a human brain, the blood that flows through veins, the breath drawn against the weight of air, all of it happens in deference to the same law that holds worlds in orbit. To lose gravity is to lose not just motion, but perspective. In a universe without curvature, there is no direction, No scale, no distinction between near and far. The human sense of beauty, of balance, of belonging, all arises from the gentle asymmetry that gravity provides. A falling leaf, a rolling tide, the slow dance of planets each, is a translation of curvature into movement. Life learned to find poetry in the pull of spacetime, to interpret gravity not only as law, but as rhythm. And when gravity vanishes, that rhythm ends. The music of existence stops, leaving behind a perfect silence. Yet, in that silence, there is not emptiness, but resolution. The disappearance of gravity does not break the universe, it completes it. The story that began in imbalance ends in balance. The curve that once bent light and time has flattened, and in that flattening lies the fulfillment of physics. The equations that described motion have reached their final, motionless truth. Still, this perfection reveals something profound, that existence itself depends on imperfection. Only because gravity broke, the symmetry of the early universe could structure form. Only because time flowed unevenly could evolution occur. Only because curvature existed could meaning arise. Without that slight imbalance, that gentle bending of the cosmic fabric, the universe would have remained a silent equation, forever static, forever indifferent. We are, therefore, the expression of that imbalance. Every thought, every word, every act of understanding is a ripple in the geometry of space-time. To live is to participate in curvature, to experience gravity not only as pull, but as connection. It links the smallest particle to the largest galaxy, the birth of a star to the birth of a mind. It is the thread that runs through all things, binding energy to awareness, motion to memory. The disappearance of gravity reminds us that meaning is temporary. The structures it created, planets, stars, life, were never permanent, only expressions of a passing asymmetry. When curvature fades, those forms dissolve, but the laws remain. The cosmos does not die, it rests. In that rest lies the same peace that existed before the first atom formed, a calm completeness that asks for nothing and gives nothing back. From a scientific perspective, this is the natural conclusion of cosmic evolution. The universe began in a singularity of extreme curvature, expanded into complexity, and will end in perfect flatness. Entropy increases until it can increase no more. Energy disperses until it can no longer move. Time slows until it can no longer be felt. The end of gravity is not destruction, but balance, the final symmetry toward which everything has been moving since the beginning. But from a human perspective, the end of gravity is the end of story. For story requires motion, conflict, and change, the bending of one path into another. Without curvature, there is no drama, no sequence, no memory. The universe becomes eternal, but voiceless. And yet, the very ability to recognize this, to imagine the silence that follows, is itself gravity's last expression. Consciousness, born from curvature, gives the universe the gift of reflection. It is through that reflection that the cosmos becomes self-aware, if only for a fleeting instant. When a mind wonders about gravity, the universe contemplates its own architecture. When a human stares at the night sky, the curvature of space-time looks back upon itself. Gravity allowed the universe to ask the only question that ever mattered. Why is there something rather than nothing? In the flat eternity that follows its disappearance, that question will no longer be asked. But the fact that it once was, that the universe once contained beings capable of asking, is proof that gravity's purpose was fulfilled. It gave rise to structure, to time, to life, and finally, to understanding. Its vanishing is not loss, but closure. The cosmos has completed its thought. If there is beauty in the end, it lies in this, that the weakest of all forces was the most powerful in meaning. It held galaxies together, built worlds, and created the possibility of love, curiosity, and wonder. Its quiet strength shaped everything we have ever known or felt. When it disappears, it leaves behind perfection. But perfection cannot think, cannot feel, cannot dream. And so, the universe ends where it began, silent, complete, and waiting. Gravity's work is done. Its story, written in stars and minds, concludes not in despair, but in understanding. For in the end, gravity was never only a law of physics. It was the translation of existence into connection, the force that allowed reality to know itself. Without gravity, there are no stars, no time, no life. But because gravity once existed, there was order, warmth, consciousness, and meaning. It was the bridge between chaos and awareness, between mathematics and memory. The universe has gone quiet now, but its silence is full. Every equation, every orbit, every heartbeat remains within it, the memory of a cosmos that once curved, and in curving, became alive. Gravity's story ends in stillness, but the stillness itself is proof that the story was real.